My name is Nassim Haramain. Thanks for coming, all of you. We've got people from everywhere. Portland, Ashland, Reno, all the way from Reno. It's great. Thank you all for being here. So today we had a big day. A lot of information is gonna flow through this room today, and we're gonna go through all the physics from universal size object right down to subatomic particle, going through consciousness, ancient civilization, chemistry, biology, and so on. So we've got a big agenda. It's going to be fun. And it's going to take a little time. So be comfortable. Make sure you are comfortable. Make sure you have enough water to lubricate your brain. Lubrication. And make sure that if you have to that you eat enough and all this, so your blood sugar doesn't drop too far. Sometimes I see people, I see smoke starting to come out of the ears. Then I know there's like damage being done. So we'll try to avoid that today. Oh, okay. Maybe we can turn that down on the board. Which one is that? That one there? Low. Okay. Is that better? Yeah. Good. I've been having a little bit of trouble with my throat, so usually I just project, but today I'm going to try to be nice to my voice. Yeah. Get good lubrication going. So, go ahead.
What's the break schedule?
The break schedule is when I see everybody's turning purple because they have to go to the washroom and stuff, then I'll stop. Actually, if you guys are really exhausted and you need a break, just let me know, because I just keep on going. I just go and go for like 13 hours. So, sometimes I forget about the crowd. And so, oops. So, but in general, I'm going to try to break around 1 o'clock or 12:30. And then we'll reconvene for a little more, and then we'll have lunch around 2, and then come back, and then I have the evening sessions. We might be here for a while. So I was asked to present a bunch of different things today that I usually don't have time to present, so I'm going to try to squeeze it in. So especially a section on the Knights Templar that I usually don't present. So I'm going to talk real fast. One thing that happens is that when I'm presenting this information, there's a certain amount of complexity. Although the concepts are really simple and you're going to get them right away, there's a certain amount of complexity. There's a certain amount of rewiring that occurs from things that you've been taught, and from just a new way of thinking coming in, and that takes a little bit of time. And what happens is that if you have too many questions that are unanswered, then it starts piling up, and that's when I start noticing people turning white, and it's like, oh my God, they're gonna explode. And so because it makes like a dam of all the things that are not figured out. So I'm going to allow you to interrupt me and ask questions, but it's gonna have to be like really, really crucial for you to interrupt me and ask questions. Otherwise, you know, I just get interrupted too much and it breaks the flow and it's really hard to get all the information in. So before you ask questions, please think about it or see if I'm going to answer that question shortly after, because commonly that happens. But if it's really piling up and you just cannot go forward in the thinking without getting those questions answered, please just interrupt me. You can start screaming, you know, jump up and down or something. I'll get the signal. So I'm going to go through the information today in a little bit of a chronological way. How I came up with it and how it changed my life and how my life evolved as the information evolved. And you'll see that although this information can get extremely complex, extremely fast, the way I learned about it, the way I learned it, makes it easy because it was just a series of logical progression that I teach typically to even 7 years old. And actually, some of the 7 or older kids commonly after the talks come up to me and say, "Are you sure the other physicists don't think this way?" And I'm like, I really checked it out. I spent 20 years checking it out. They really don't think this way. And it boggles their mind because it's kind of obvious and it's kind of instinctive. It's not kind of instinctive, it's instinctive. And funny, it's a funny thing that like commonly now, they think of these thoughts as counter-instinctive. But I think they're quite instinctive. And they got counter-instinctive as a result of confusion. In the early ages, when we learned some of the foundations of our reality at school. So that's really what happened. At the age of 7, I had a bunch of esoteric experiences. And we're not going to get into that, but I had an intuition, and I definitely had experiences that told me that there was something else than the reality we observe. That like the reality we observe is just like a little bitty part of what's going on. Just like if you'd like the electromagnetic spectrum has a section that we see, and then there's a whole bunch we don't see. And the part that we don't see has huge impact on the physics of the part that we see. And I felt that very early, you know, until they discovered, for instance, X-ray and infrared and long wavelengths and so on. They thought that all there was the visible spectrum. And, you know, it became clear later on that there wasn't, that there was much more. And I think that it's becoming clear now in current physics that there is a whole bunch of stuff going on that we're not aware of that is actually generating the part that we are aware of. So when I was 7, I noticed this. I had experience that made me notice this. So when I got to the age of 10 and I got into my first geometry class, and the teacher went to the blackboard and said, "Today we're going to learn about dimensions," I thought, that's it. Oh my God, finally somebody's going to explain to me what's this other world about. You know, these other dimensions that I felt were present. And I got really excited. I was like, oh my God, finally an adult that's going to talk about something real, you know, and something that makes sense to me. So the teacher started the lesson and I got really, really disappointed. He didn't tell me anything about the dimensions that I was experiencing earlier on in my life. But he actually gave me one of the major keys to the evolution of this theory and to its conclusion and into its proof that is now being peer-reviewed in many universities around the U.S. and from scientists that are looking at it from NASA and so on. So it's really exciting. And that, at the age of 10, made a huge difference. What the teacher did is he went to the blackboard, and we'll call this our blackboard today, and he made a dot. And he said, the dot is dimension 0, and it doesn't exist. And I went, okay, I can see it, but it doesn't exist. And, you know, I was near the door in the back of the room. I was always closest to the door because I was having so much problems at school. And, you know, I'm like, okay, whatever, you know, if you got a dot that doesn't exist, I can go with that for now. And then he said, this is a series of dots that he placed together and made a line and said this is dimension 1 and it doesn't exist either. It still doesn't have volume. And, you know, that seems consistent to me. Then he placed a bunch of lines that are made out of dots together, made a plane, called it 2D, and said this is the dimension that you live, that your comic strips lives in. It still doesn't exist. It still doesn't have volume. Well, until then, although, you know, it was kind of a bizarre approach, it was consistent. But then he did something that seemed like a miracle. He grabbed 6 of these planes and put them together on the blackboard, made a cube, and said, this is dimension 3, 3D, that one you exist in. And I was in the back of the room, and I'm like, oh my God, how can that be? And I could tell that all the other kids in the room were like, huh? You know, but nobody was saying anything. I wasn't about to put my hand up because I knew the next thing that was going to happen is the door was going to get open and I was going to get kicked out again. So I didn't want to do that. So I didn't say anything, but it didn't make sense because it's like that was a mystery cube. Because if you have a dot that doesn't exist, that makes a line that doesn't exist, that makes a plane that doesn't exist. You slap 6 non-existing planes together, you don't get existence. All you get is non-existence to the 4th. Okay? It's got nothing to do with existence. You just have got a bunch of non-existent dots together. So nothing exists. And that was not logical. I have a tendency to be an extremely logical human being. And it turns out that Buckminster Fuller, I found out later, had the same problem at school. He wrote about it in his book. And he didn't understand how this worked neither, and he didn't thought it was correct. And actually, through my research, I found that this is an ancient riddle. It's mentioned in ancient manuscripts that are from the Middle East and so on, and there is all sorts of treaties about this problem, although this problem is the foundation of our understanding of physics and dimensions. And all of our knowledge is actually based on it. And it creates a lot of problems. This simple riddle that is unsolved has generated a whole set of distortion in our societies and in the way we do physics and the way we understand the universe and how we relate to it. And we're going to see that today. We're going to see this error just come back and bite us in the butt every time we come around the corner. You all following this?
Yeah.
Well, okay. Well, I was going home from my school that night, and, I had an hour and a half bus ride back home. And that's because I kept on getting kicked out of the schools closest to my home. So I had to go further and further, and some physicist once told me, actually, I was furthering my education that way. And I thought that was true because I had all this time to think when I was in the bus. So I was thinking, and I was going in this bus, and I'm like, I'm not living another day without solving this. I had no idea that nobody had been able to solve this or anything like that. Nobody told me it was not solvable. Nobody told me I shouldn't be working on this when I was 10. So I was in my bus going, I cannot survive another day on this planet without knowing what the heck a dimension is. And what is this dimension I'm in? And what are these other dimensions I'm experiencing, or these other energies I'm experiencing, and so on. So I'm thinking, and I'm thinking, and I'm thinking, and I've got a goal in my head that I'm going to solve this before I get off the bus. So I'm, the bus is getting crowdier, and, it's like more and more people in there. And it's getting really kind of tight. I'm like sitting on this little bench, and I'm getting squashed, and I'm getting really uncomfortable. And I'm trying to think about all this, and I'm like, I got to find a solution. And at one point I thought, well, maybe I should like try to get my mind out of this bus because it's just getting too crowded in here. So I started to expand my mind, and I rose above the bus, and I saw, in my mind's eye, I saw the bus becoming a dot. And then I rose further, and I saw the Earth becoming a dot. And I rose further, I saw the solar system becoming a dot. And I rose further, and I saw the galaxy becoming a dot. And then I flew back into the galaxy, into the solar system, and back into the, I saw the Earth, and then I saw the bus, and I found the bus and flew back into my body. And I thought, wow. And I looked at my hand, and I went, I flew into my hand in my mind's eye, and I saw it was made out of dots. I didn't know those were called cells, And then I flew into one of the cells in my mind's eye, and I saw that cell had to be made of thousands of little dots we call atoms. And I flew into, actually, billions of little dots we call atoms. And then I flew into one of those dots, and I saw that inside the atom there was a whole bunch of other dots in the middle, and so on. And actually, that was my first glimpse at the fractal nature of the universe. And I thought, oh my God, I know how to solve this. It's a dot within a dot within a dot to infinity. And the only thing that exists is the dot. Within each point, all information is available. Each point contains the whole. So the only true existence is the point. And from that point, or from an arrangement of points, you get all of reality. Wow. I was onto something. I got really excited. It's like, that's the way it goes. Each point contains the whole. Each point has all information. Each point is connected to all other points in the universe. And then the universe arranges the points in all sorts of different ways and makes all of the things we see. Well, that would mean that each point had to contain infinite amount of energy, infinite amount of information. Well, I got excited, and I'm like, oh my God, I got to tell my mom. So I went back home, I got out of the bus, and I'm all excited. I'm like walking on the cloud. I'm feeling like I've got this illumination, and I'm on my way to changing the world and all this, and I get home and I wait for my mom. My mom comes back from work and I'm like, Mom, I figured out something at school today. It's real important. She smiles and she's like, oh my God, he finally had an A in the test or something. She thought I did something real good at school. And I'm like, Mom, I figured out that each point contains the whole. Each part of you has infinite involved in it, and each point has a connection to everything else. And I'm telling her all this, and she looked at me, and she's part of your curriculum at school, is it? And I think you should go back to it. You're not doing, and and my mom is kind of a pragmatic person, and she's a Roman Italian, woman, and she just looked at me and said, anyway, today I don't feel infinite. I'm not feeling infinite, so why don't you just go back to your curriculum, Go do your homework or something. And I got disappointed. It crushed me. I was like, oh my God, she's right. How can a point contain the whole if a point has a finite boundary? If the body has a finite boundary, how can it have infinity in it? So I was like, oh, I gotta go back to the drawing board on this one. I was like, that doesn't really work. How do I do this? Well, it turns out that that's gotta be one of the largest errors that is going on in our understanding of physics and our understanding of the way the universe functions and our place in it. That is, that infinity and finite system are opposites instead of complementary. But how can a finite system and an infinite curvature be complementary? How can the two be together? I knew when I was 10 that there was a solution to this, because I knew I was right, because I had seen it in my mind's eye. I instinctively knew it. Actually, most children I talk to, if they haven't gone through that first lesson of geometry, know this. They think of the universe as infinitely big and infinitely small, all embedded into each other to infinity. In general, they think of that as being quite logical. The kids are not the only people that thought of this. Do we have sound on the computer? One famous physicist, Carl Sagan, wrote a book called Contact. And then there was a movie that was made out of that book. And the movie starts like this. Thank you. Okay, this is a little bit hard to see. It's the edge of the Earth. There we go. And so we're moving away from the Earth in space. And as we move out, we catch up with all the radio waves that were sent into space by the Earth. So it's like almost going back in time. goes Saturn. Now we're exiting our solar system. And shortly we'll be exiting the arm of the galaxy we're in. Here's our galaxy center. And now we're moving faster and faster away from our galactic supercluster. So the concept of a universe within a point, was there quite definitely described. Let me tell you as well that the concept of a universe coming out of a dot is not that outrageous. The current theory of the Big Bang says that we all came out of a dot the size of a Planck's length, 10 to the minus 33 billions of times smaller than an atom, and all of our universe. The only difference here is that this view says, no, it didn't all emerge from one dot that decided to make a universe. All dots contain the possibility of a universe in it. All dots are connected to all other dots. And so here, then Hollywood came up with their version of this concept. And since they're the man in black, they have much faster technology. They can move much faster than anybody else. So that's the end of Man in Black movie. They have extreme speed because they got all that alien technology. Little marbles we are. So these concepts have been around, except they've never really been understood because, again, how do you fit infinity in a finite space? And it's crucial that we understand how we did it. Well, when I grew up, eventually, I found the solution. I found the answer to this. The solution is what is called a fractal. And I'm going to show you very, very simply how infinity fits into finite. How infinity and finite systems are absolutely complementary. And that each point has the potential of having all information in it. I'm going to show you this in a geometrical way, so it's really easy to understand. And it just happens that the way I'm showing you this turns out to be very crucial to the way systems are organized and generate the geometry of our reality everywhere we live. So we're going to make a boundary, a circle, and inside it we're going to inscribe a tetrahedron, or an equilateral triangle in this case. The boundary could be a sphere, and the middle triangle could be a tetrahedron. Okay? So this you can visualize in 3D space, in spherical coordinates. Now, the universe is polarized, positive, negative, male, female, white and black. So this has a polarity, right? And generates a reverse equilateral triangle. Now, I'll give you a hint to the ancient civilization part of this lecture we're going to have today. Right away, we have one of the most commonly found symbols in all ancient civilization around the world. A circle with a double triangular polarity inside it, commonly referred as the Star of David, or the Shield of Solomon, the Star of Zion. It's found on the on many walls around the world of ancient civilization. Now, if you keep adding triangles, you get smaller stars. Smaller stars of David. And then you can keep adding them again, and you get smaller stars again. Now, at each level of the fractal, you're going to generate a boundary. This is an important part to understand. Each level generates a boundary. Again, boundaries at the next level. And now I'm making smaller boundaries. See, I didn't put them all around because I got lazy. And then now I'm making smaller boundaries again. And smaller, and now they're so small you can't see it. Now, if I give that equation to my computer and got the computer to just keep making boundaries, keep making smaller and smaller triangles, it would continue to do this to infinity until it heated up, melt down, and I'd have to go and get myself a new computer. But assuming it didn't do that, it would keep making smaller and smaller triangles to infinity. And I could give it a code so that every 5 iteration or 6 iteration, it would zoom in so you could see it again, and then starts making more triangles, and then zoom in, and then so on to infinity. However, although I can place an infinite amount of triangles, I will never exceed the first boundary I made for myself. Never. I just showed you how infinity fits in a finite space, or a so-called finite space. Because you can divide to infinity within the circumference of a circle. What does that mean? Why is that important? What does that do to your life? What does that do to the way we do things on this planet? Well, let me give you an example, even if it's just for physics. We built faster and faster and faster accelerators that cost billions of dollars to build, to get smaller and smaller and smaller and smaller. Now we're at like millions of times smaller than an atom particle, actually. And we're building accelerators now in Geneva, in Switzerland that are costing $300 billion, I believe. 5 countries had to get together to build it, right? To get even smaller particles. Well, if we understand this principle, we would understand very quickly that you can keep building larger accelerators and you can keep getting smaller and smaller particles. You can always keep dividing. So we would give up the search for some fundamental particle and that's going to end the search for particles, and we would start to understand that what we need to discover is the dynamics of the division, the dynamics of the quantization. You understand? Not, how far we can go into infinity. Just so that some physicist can put his name on it and get a Nobel Prize for a new particle. But further, what does it mean to you? It means that if this is true, every one of your atoms, every one of your cells has infinite potential in it, has infinite connectivity to everything else. That each one of your atoms is a mini black hole. Because if there's infinite amount of particles in it that can be divided, that means it has infinite mass. Most people say, I can't envision infinity. It's a good point. You might have to take a lot of coffee in the morning. But it's like, I can't visualize infinity. If it's true that I have an infinite nature inside of me, how is it that I can't see it, that I can't visualize it? That's a good point. Well, the reason is that most people try to envision infinitely large when they think of infinity. So that is limited by your senses because it's external to you. However, here we see that through infinite division we can generate singularity, a link to all other things. So when you try to visualize infinity, you might want to turn your senses inwards and go towards the infinitely small that's contained in all of your atoms and all of your cells. Well, just happens that all of the masters that have walked the earth have been trying to tell people about turning their senses inward through meditation, prayers, and so on, to connect with their infinite nature. The Buddha, Jesus, all these people said the temple of heaven is within you and within everything. That's the description of a fractal, my friend. The thing is that it was never appropriately applied to physics. It has huge repercussions in physics because it completely changes the way we look at the structure of reality if everything contains the whole. So you see, already this is a key to understanding your nature and your potential. How many times in the year do you turn your senses inward and connect with your infinite nature? And so I was really excited about this because it seemed to say as well that the universe would be expanding and contracting, right? If everything goes towards infinity at the center of all atoms, then the universe is contracting as much as it expands. And I could see how the external part of my existence is the expansive part, and the internal part of my existence is the contractive part. So I started to think in those terms when I was actually 11. And I learned to meditate. A young master of meditation from India taught me to meditate. And I was really excited because I was discovering a whole world within myself that seemed to have infinite potential. So I started to spend more and more time concentrating inward and connecting with that part of my existence. And I started to think that there must be a balance between the expansion of the universe and the contraction of the universe. And the contractive part of that balance equation is the part that generates. And the radiating part is the part that alienates, that destroys. Yet, all of our science, all of the knowledge is based on the radiating part. There's nothing we've really discovered since fire. We explode everything. We put fuel in a rocket, right? Tons and tons of fuel, and we light the bottom, put a few people on top, and pray that they're going to survive the experience. That's our approach. We put fuel in our car, and we explode it in a chamber, and we push a piston up and down. It's all about explosion. And we think the universe is expanding. When much later, I was brought to Georgia Tech to have a conference, kind of a debate with other physicists. These are very well-known physicists, highly regarded, older people that had their students there. And we were talking about things. Some of the students were there. They came in and out. We were, looking at equations. We had all this stuff on the big wall there, on the blackboard. And I showed up with this book. This is the only book I had with me. I had maybe another few, but that was my main book. It's called Gravitation. It's a classical book about relativistic equations. It's written by Messner, Thorne, and Wheeler. Those are legends of physics. Wheeler having worked with Einstein and so on. And it's a brick, you can see. And that's why it's called gravitation. When you pick it up, you know everything you need to know about gravity. And I was going through all the equations, and I could see that the physicists were starting to get upset with me. I was, kind of going through, the way they think of the universal dynamics and the universal expansion and all this. And I finally said, okay, if I understand your model right, and I opened Gravitation on page 719, and I said, if this is correct, then the universe is something like this, which they show you after about 1,000 equations. The model for our universe is a balloon with pennies glued to it. So what you do is you take a balloon, you take a bunch of pennies, and a glue gun. And you glue the pennies to the balloon, and the pennies represent galaxies. And then as the balloon inflates, the galaxies move away from each other. generating the universal expansion we observed with the Hubble. It's called the Hubble constant, or the Hubble expansion, and is observed by various modalities, including telescopes. And so I'm going through this with them, and you know, you got to realize these guys are very accomplished physicists, and you know, they're looking at me going, "Oh my God, this is like kindergarten stuff. You know, if you don't know this stuff, you should go back home and study a little more before you waste our time." And so I was like, well, you know, what I want to know is where is the equation, because I really looked through all your stuff, and where is the equation for this guy? And, you know, the room became quiet. And I was saying, well, you know, this is definitely a component of the dynamics that are going on. And I said, if you keep drawing, you know, if you don't stop at the face, and you keep drawing the rest of the guy, you'll notice that when the balloon expands, the lungs contract. For every action, there's an equal and opposite reaction. First law of physics. That hurt. Everybody had a blank look on their face, and the room became so quiet you could hear a pin drop. And I could see my dear friend and sponsor across the room going, "Oh, you're doing damage." Kind of obvious. Completely missed. Obviously, if the universe expands, then something is contracting. And that dynamic of expansion would be a feedback, right? Expand, contract, expand, contract. And it would have a very specific topological structure, meaning it would look in a very specific way. It would have very specific dynamics for things to be able to expand and then contract and so on. So, you know, when you think about it, and I was thinking about it for years, if you radiate, if you look at the universe, you find that everything in the universe radiates. What does it radiate in? In the vacuum of space. Well then, the vacuum cannot be thought of as empty, can it? Because no energy is lost, no energy is gained. So if all the suns, all the stars, all the galaxies, all the black holes, everything we see radiates into the vacuum, then the vacuum must be full. Full of energy. And it was clear to me that then the vacuum must be the contractive side of the event horizon, the contractive side of the structure of reality, the part we don't see. Why? Because it's contracting towards infinity, moving away from us. It appears to us as vacuum. So I was puzzled about that, and I remembered my first class of physics. So again, you know, I'm all excited. Now I'm about 16, and I'm going to my first class of physics. Well, actually, I'm like 14 or, you know, 15, something like that. And I'm like, oh my God, today I'm going to go into my first class of physics. I'm going to learn everything there is to know about atoms and reality. So when I sat, the first thing I did is put my hand up, and, you know, the teacher didn't know me better at the time, so he asked me what I wanted. And I said, what is an atom? I was surprised to hear the response. I thought, oh, he's just going to spell it out. What the heck is an atom? And he said, oh, that's way too complex for a first physics lesson. And in fact, we are not quite sure what an atom is. I was like, huh? You mean that in all of the years of physics that have been going on this planet, you guys still don't know what the heck is an atom? How can you tell what anything else is then? Right? And so I was like puzzled, but one thing he said is that one thing we know is that the atom is made out of 99.99999% space. And I went, oh, space. Mostly space. Everything you see, everything you touch, everything is mostly space. 99.99999%. That includes you. You are 99.99999% space. And it was like, wait a minute. That the universe is connected by an unseen force, right? What would be the thing that would connect all things? Space. That's the only thing that's everywhere. And that's the only thing that all energy is radiated into. So I start to think, maybe it's the exact contrary. Maybe the atom is just a result of a division in space. Aha! Like the fractal structure we just saw. Divisions of space to infinity. Now it starts to look a little different, doesn't it? Is your brain starting to hurt? That's okay if it does. It's normal. Don't panic. It'll get better. But imagine you're doing music. You need silence to be able to cut it, to make music, to make a beat. If you're making reality, you need space to define the reality in between. So space, reality could be just various resolution, right? Various divisions of space in a fractal structured vacuum, which is some of the math we just published recently. It's becoming extremely popular, the concept of a structured vacuum, energetic structured vacuum. This is in advanced physics. So I dug a little bit more after that first class in physics, and I found something that blew my mind. Much later I did find it. And it says this. It's in gravitation. Present-day quantum field theory gets rid by a renormalization process of an energy density in the vacuum that would formerly be infinite, if not if not removed by renormalization. Now people, you don't know what renormalization is. What they tried to do to me at school. It didn't work so good, can you tell? We'll talk about renormalization in a minute, but here, energy density in the vacuum that would formerly be infinite. That means that current day physics for subatomic particle, quantum physics, has to have a huge amount of energy in the vacuum for all their physics to work. Why do they try to remove it by renormalization? I'll explain that right now. There is two infinities in physics. That sounds like a misnomer, but that's the way it is. One infinity is infinitely small quantities. You know, you mix this quantity with this quantity and you approximate it, and you know, infinitely small. At one point you say, okay, well, it doesn't matter, it's just bits, you know, like infinitely small. It's okay, you can ignore infinitely small. And then there is another infinity. That one has a highly technical term that is found in physics books, and that term is nasty infinity. Yes, it's used in physics commonly. Nasty infinity is not infinitely small, but infinitely big. When you find something that's infinitely big, you can't just say, oh, I'm just going to ignore that. Right? I'm just going to ignore infinite amount of energy. I don't think so. You got to do something with it. And that's why they call it nasty, because it's like, oh my God, what do? We've got infinite amount of energy in the vacuum. You know, nobody's going to believe us. So, there's a thing in physics is that if you find nasty infinity, you got to somehow get rid of it. And if you don't, then your theory is no good. It's discarded. And the way they came up with a way to get rid of it is that they use a renormalization process. Basically, they take the infinitely large number and they cut it. Okay? And then they try to shove it under the carpet somewhere, and they don't talk about it. So, basically, you can graduate with a PhD in physics and never have heard that the vacuum density is infinite at the Planck's distance. Right? It's called quantum fluctuation. Now it's getting more talked about because of many, many different reasons. But so it's becoming more popular in people. But only a few years ago, if you talk to people about, you know, infinite density in the vacuum, they'd look at you and go, oh my God, what are you talking about? They think you're talking about a vacuum chamber in a laboratory somewhere. So I was, you know, so how did they renormalize this? Well, they took a thing that's called a Planck's distance. And I'm not going to go into too much details on how they derived this number. But it has to do with the Schrödinger's equations. And the Planck distance is 1.616 multiplied by 10 to the minus 33. This is a small little dot. And basically they say this little dot is the smallest thing the universe does. Right? We'll make the dot. See? Here's my Planck's length. And they say the universe goes to that small and then stops. It's like, I'm done. I'm out of here. This is way small enough. I ain't doing nothing smaller. Okay. And then what they did is they went and see how many of these Planck's lengths, right, would fit in a centimeter cube of space, to try to renormalize the infinite density of the vacuum, to get a closed number. So they stacked the Planck's length into a centimeter cube of space, basically, and calculated that the density of the Planck's length would have to be 10 to the 94 grams per centimeter cube. 10 with 94 zeros of these Planck's length in a centimeter cube of space. Well, now they had a finite number. But what is that finite number? Let me give you an idea. If you took all the stars we observe in the universe with the largest telescope on Earth, actually off the Earth, the Hubble, and you stuck, and we see 100 billion galaxies. Each galaxy has over 300 billion stars in it. Most of these stars larger than our solar system. Okay? And you took all that stuff with a huge trash compactor and you squashed it into a centimeter cube of space, you still would not have 10 to the 94 grams per centimeter cube of density. You'd still be short. Okay, so you guys got a finite number. It sounds pretty infinite to me. Maybe we should learn to deal with infinities instead of trying to renormalize them. Because, you know, people got Nobel Prizes for this. So 10 to the 94 grams per centimeter cube is actually what's called the vacuum fluctuation density in quantum space. Meaning that the vacuum is not empty. It's extremely dense. But why does it feel like the vacuum then? It doesn't feel so dense either after, you know, a night at Burning Man. With what happens there, you know, how can the vacuum be so dense? Well, if the vacuum is everywhere and infinite in nature, then it's in perfect equilibrium. And if it's in perfect equilibrium, there's no way you're going to feel it. It can have infinite forces in it, but if it's in perfect equilibrium, you're not going to know it's there. Just like a fish inside the ocean, in the water, will never know it's in the water until you take him out of the water and it feels a different density. We have no way to feel a different vacuum. So we think of the vacuum as empty, when actually it's full. And you can come to those conclusions yourself by simply realizing that if everything is radiating in the vacuum cannot be empty. So I was you know, amazed, and I'm like, okay, well, let's go with this. The universe is expanding. The vacuum is contracting to infinity. And all of reality emerged from the feedback between expansion and contraction. It becomes really clear then that the expansion part would be the electromagnetic radiation part of the universe, and the contractive part would be the curvature of space-time and the vacuum energy going towards singularity at the center of the system. So, yeah, I'm gonna elaborate on it. It became really clear, well, basically, that if there is an expansive and a contractive part of the universe, the expansion part is what we see as reality, which is the radiating electromagnetic emission that we see. A star, a planet, an atom, all radiate energy. That's why we see it, right? And the contractive part that we don't see would be the vacuum energy curving, space-time curving into it, generating singularity, generating the gravitational field. So now I had an inkling about the relationship between electromagnetism, radiation, and gravity.
Gravity goes into the singularity.
Gravity going towards singularity. Space-time curving towards singularity. Now, I later realized that that wasn't that outrageous of a thought. Because when Einstein wrote his field equations, he didn't solve them. Einstein just wrote the expressions. It's 10 differential equations. He couldn't solve them. A physicist that was fighting on the Russian front, right, while dodging bullets, was working hard at solving those equations after they were published. His name was Karl Schwarzschild. And he generated what's called the Schwarzschild solution. As soon as he solved Einstein's field equation, he sent a paper to Einstein with the results. And Einstein presented it to the German Academy of Science, and it became the first solution to Einstein's field equation, which we still use today. Karl Schwarzschild died 2 weeks later on the front and never had time to give further complexity to his solution. Basically, he did it without rotating the field. At first, he was trying to estimate, so he didn't have a rotating metric. And we'll see a little bit more about that later. But the first solution to Einstein's field equation was a black hole. It's called a Schwarzschild singularity. It made a black hole. But because when you go towards singularity with Einstein's field equations, they go to infinity, nasty infinity, that part is ignored. It's called the unsolved nonlinear part of Einstein's field equations. So we use only the weak part of the gravitational field. The part that's not curving very much towards singularity. The part that's much weaker on the outside of singularity. You guys see where I'm going with this? Oh my God. big omission. Infinite amount of singularities just scrapped because it didn't fit our concepts. So I started to think, well, okay, if the universe is expanding and the universe is contracting, then there's got to be geometry to describe that. There's got to be a structure that describes the contractive side. The expansion side was pretty easy to figure out. If things are expanding from a point, from a center, then they must be expanding radially. It must make the geometry of a sphere. Right? The expansive part being the geometry of a sphere. That's what we see. A sun, a planet, a galaxy. Galaxies have galactic halos that are perfect spheres around them. Atoms, cells, whatever. Spheres. So we see the sphere part because that's the expansion part. But what I wanted to know about was the contractive structure of the vacuum. Why did I want to know about that? Because if I understood the structure of the contractive part of the vacuum, then I understood the geometry of the foundation of creation. Do you guys follow me there? Because if that's what creates, if that's the general active thing, that's the thing that holds things together, then that's the key to the force of creation of all things. If you have a sphere or a ball on the end of a rope and you spin the rope, you're going to feel a force outside pulling away from your hand, right? That is not a true force. It's called centrifugal force. It's not a true force because the only reason that force is occurring is because the ball is attached to the rope, which is attached to your hand. The centripetal force, the force that's holding the ball to the center, is what's making it go in a circle. Without the string, the ball is going straight and there's no force. You guys follow me? So actually the force that holds to the center is the primary force from which the illusionary radiation occurs. Do you see what I'm saying? I mean, that has huge implication in philosophy as well. Because if you go inward deeper and deeper, then you would expect more and more radiance to occur. Because you have a feedback relationship between the internal gravitational collapse and the external expansion of the electromagnetic field. So I was really excited about that, but I didn't know what was the geometry or the structure of the collapse. I knew one thing, is that the geometry of the collapse had to be in equilibrium. So I looked and I thought, well, if the sphere is the highest volume possible, which it is, then the geometry, so it's the highest volume possible because it's expanding, right? Then the geometry of the collapsing vacuum must be the smallest geometry possible. The smallest volume, the volume that's collapsing. And that is a tetrahedron. Everybody here knows what a tetrahedron is? Okay. While I'm traveling, it's kind of hard to bring all my models. But this is a double tetrahedron. Okay, there's two there. Actually, there's 8 making an octahedron in the middle, but we're not going to get too complex here. If you have a tetrahedron, you have 4 faces, 4 equilateral triangle faces. It's like a pyramid with a triangle base. Okay? It's like 3 triangle faces with a triangle base. It's the smallest volume possible. And thus, that had to be the final geometry of the collapse. Well, you know, when I was thinking about these things, it was almost 15 years ago, there wasn't people like if you go in Sedona right now, you know, like, or, you know, Burning Man or whatever, you know, there wasn't people going around with tetrahedrons on their heads and like living in tetrahedron houses and, you know, having tetrahedron cars and stuff like that. You know, at that time, nobody even knew what the heck was a tetrahedron. I mean, it was not so common, although, you know, that comes all the way back from the Pythagorean school and then Plato schools and so on. So I was, you know, at the age of 16, after all my encounters with current physics and so on, I decided I was done. And it's great because I just went to the Einstein exhibit in New York and found out that Einstein did the exact same thing and quit school at 16. But I was, you know, I couldn't keep doing this. I was just running into troubles everywhere I went. And so I started to teach skiing. Because I was a good skier, I figured I can live that way and do research at night. So I was doing research at night and skiing every day, teaching skiing, being in nature. And I was like, well, you know, after years of skiing, I taught skiing for 15 years. I became one of the top ski instructors in Canada. I was one of the 20 top ski instructor in Canada, ski coach. And I was very successful. And I was going from Canada to Australia, New Zealand in the summer to do their ski season there. And then back to Canada. And then back to Australia. And then back to Canada. And I was freezing my butts out. I had no time to unfreeze. I had like a week and a half to 2 weeks on, you know, Fiji Island, you know, in between seasons. And I was just not cutting it. So after a while of doing that, I got tired of it. And one summer I said, that's it. I ain't teaching skiing again this summer. I'm going to teach scuba diving. So I'm, you know, decided to thaw out one summer and teach scuba diving. And I had been scuba diving since I was a young kid, so I knew I could teach scuba diving. So I opened a map, and I thought, okay, I got to be south of the border. It's got to be extremely hot. And so I took a map of Mexico, and I found this little island called Isla Mujeres. And I thought, wow, you know, I was a ski instructor. Island of the women, man. That sounds good to me. So I decided I was going to go to Isla Mujeres. So I went down there and I got a job as a dive master, and I started to, you know, dive master down there, and I learned a lot and all this. And then one day I had a day off, and I decided to go for a little expedition. And I hadn't seen the pyramids, so I decided to go to Chichen Itza, the pyramids of Chichen Itza. Well, you know, it's like you get in the bus. You know, I had to take the ferry from the island. I got in the bus, you know, with the chickens and the pigs and everything. And I'm going through the jungle, you know, for hours. And then finally, you see these pyramids sticking out of the jungle in the middle of nowhere. And it's like, huh? And they're like these huge monuments. And I get onto the site, and I'm walking around, and I'm like going, wow, how did this get here? So I'm climbing on top of the pyramid, and I figure I meditate on it, so I'm sitting down, I'm trying to meditate, and sure enough, as soon as I close my eyes, I hear, a group of tourists coming off the stairs on the other side with a tour guide. I'm like listening, trying to meditate, and and I'm listening to this tour guide, and the tour guide is saying how, all the rocks were cut in the quarry over the mountain range we see in the distance, and that they were carried from there, cut with copper tools, and then carried from there on with vine ropes on logs across the mountains, across the jungle, down the mountains into Chichen Itza, and then assembled into this amazing monument we were standing on. I'm listening to this, and I'm going, really? And then he mentioned that actually the monument was actually carved and cut perfectly so that on the solstice every year, when the sun rises, it casts a shadow of a snake going up the stairways, and the snake head is carved on the bottom, and it really works. And I'm listening to this, and I'm like, wait a minute, that doesn't sound right. These people, like thousands of years ago, were going around with huge stones across jungle, across mountain range, right? And like putting them in this perfect building that's amazingly well aligned to astronomical events. And it's not like you can build the pyramid and then like get Joe out there and get, okay, Joe, the sun's rising now. Okay, pick it up now. Okay, a little bit to the left. You can't do that. You gotta calculate that stuff in advance. And those are not simple calculations. Those are very complex. Just happens that most of these buildings we find around the world are pyramidal. Most of these enigmatic buildings are pyramidal, and most of them are aligned with incredible accuracy to astronomical events. So as I was listening to this, and I'm a climber as well, and I know rock, and I know that you can't cut rock with copper. And I find out later on that archaeologists say, oh well, they had a way to temper the copper so it became hard. And I was like, okay, can anybody else do that? No. You mean that with all the millions of dollars that are invested in research and metallurgy, nobody is able to harden copper, but the ancient people thousands of years ago could do it? The other thing is that, have you ever tried to pull rocks on logs in the jungle with vine ropes? And now, you're talking about people that didn't have the pulley. So now you got to stack these rocks to make your pyramid without a pulley. That didn't sound right to me. Just because I'm a type of a logical person. And I was standing on top of this pyramid, kind of scratching my head, going, oh my God, that doesn't sound right. There's got to be some mystery we're missing here. And then it hit me. It's like, wait a minute. This is a pyramid. And there's pyramids all around the world from these ancient civilizations. Why were they all building the exact same geometry? Why didn't they make a cube? What's going on? What's with this pyramidal thing? And I thought, okay, maybe this is a long shot, but maybe they knew something about the fundamental structure of the vacuum. Maybe they knew something about the logos of reality, the fundamental structure from which everything emerges. And maybe pyramids are involved in that. So when I got back home, at the time I lived at Whistler, Canada, a big ski hill, I went to my local library. Well, you know, in a ski resort, library is not, you know, so elaborate. But I was looking for information about ancient civilization, and the first book I came across was titled Mystery of the Mexican Pyramid by Peter Tompkins. And I thought, oh, that's a good title. Definitely is a mystery there. And I opened it randomly, if there is such a thing. And when I did, this graphic, this is not my graphic, this graphic was on the page. A tetrahedron within a sphere. Well, I had spent by then a very long time coming up with the idea that a tetrahedron and a sphere must be part of the geometry of reality. And it was the base of my theory. And to find this in a book that talked about ancient knowledge was crazy. I'm like, oh my God, they beat me to it by 2,000 years. Dang, I was going to copyright this. And I was like, oh, what's that doing there? And, you know, there was the whole elaboration about the relationship of a tetrahedron to a sphere, showing that a tetrahedron has a very interesting relationship to the sphere, where it intersects the sphere at exactly 2/3 down, 1/3 up, if one point is on the south, or if one point is on the north, then 2/3 up and 1/3 down. And it intersects the sphere at exactly 19.471222064 latitude, which is exactly where I live, actually. I live on the big island of Hawaii, and that is on one of those points. And I was puzzled. How did that get in there? Did somebody listen to my thoughts? But I realized that this graphic was the result of a paper that had been published by an American engineer that had been hired to survey the huge city, ancient city of Teotihuacan near Mexico City. This is where there's the Moon Pyramid and the Sun Pyramid and the Way of the Dead and all this stuff. His name was Hugh Holliston Jr. and the paper was published by the American Society after 20 years of him putting, surveying all of the buildings there. Well, when Hugh Holliston Jr. started to survey the buildings at that ancient city, he found something very bizarre. He found that all the buildings there seems to, like the large buildings, the temples and such, seems to be in the exact appropriate place to describe all the orbits of our solar system, with the Sun Pyramid, the Moon Pyramid, and everything. He found all the orbits, including Pluto and Neptune. Now, Pluto and Neptune, Neptune, I think it was late 1800s. Pluto was discovered by us early 1900s, 1920-something, by the observatory in Arizona there, in Flagstaff, Arizona. So, how come these people, thousands of years ago, had these orbitals? Not only did they know these planets were there, but it had the appropriate placement to generate their orbits. Those are extremely difficult things to figure out, especially if you can't see it. And so that blew his mind. And he started to continue to investigate, and he found that there was some incredible mathematical recurrence in all of the measurements that he was taking. And that recurrence, these mathematics that kept on creeping up, were always the same. And he figured out that they were pointing out to the mathematics of a sphere and a tetrahedron embedded in it. And that's why he put that graphic in his paper, saying that if these people were trying to communicate something to us, they were trying to tell us about a sphere and a tetrahedron. He didn't notice, though, that even that city, right beside Mexico City, that ancient city, is exactly at 19.47 latitude on the Earth as well. So not only does it have the mathematics of a tetrahedron in a sphere in all of its layouts, but as well it is placed on the Earth exactly where a tetrahedron would intersect a sphere.
What's the third point?
Well, this is a grand circle, all around the Earth. So depending on where you put this point, these other points will move, right? But if you put this point at the big island of Hawaii, then Mexico City is somewhere in the middle here, in between these 2 points. This one is near the coast of Africa, I believe, and then this one is India, the Daikini temples in India. And so I was amazed that this engineer had come up with this. And I was confirming, that imagine that there is a fundamental structure to the vacuum, that there is a fundamental structure to reality. You would expect that throughout the ages, we would have come up with it, because it would be inherent in us. It would be oozing out of us. So I thought, maybe they came up with this then. But I knew there was something wrong, because a tetrahedron on its own is not in equilibrium. And I knew the vacuum geometry had to be in perfect equilibrium. So I had to find something else. Well, at the end of his essay, Hugh Holliston Jr. mentioned a very important thing: the isotropic vector metric from Buckminster Fuller. He said that the mathematical constant that he got from his surveying of that ancient city pointed out to the square root of 9/8, which is the mathematical constant for an isotropic vector metric generated by Buckminster Fuller. Bucky thought that this metric was the fundamental mathematical blueprint of the universe. Well, Bucky was quite eccentric. However, many of the things that Bucky came up with were later confirmed. So he's getting more and more acceptance of his work, although he's not around to appreciate it anymore. But the blueprint of the universe, he thought, was the isotropic vector metric. What is this thing? It's 10 tetrahedron on the bottom. This is called a 4-frequency isotropic vector metric. So 10 tetrahedrons on the bottom, 3 in the middle, I'm sorry, 6 in the middle, 3 on top, and then 1, making a huge tetrahedron on its own. Can everybody see this? So there's actually 20 tetrahedrons in an isotropic vector metric. And if you take only one face of the isotropic vector metric, right, just a plane of it, then you have 4 faces on the bottom, 3 faces on the second level, 2 faces on the third level, and 1 face on top. Everybody sees this? Okay. Well, when I found the isotropic vector metric, I thought, well, I'm interested about negative space. So let me take off the tetrahedrons and see what's in between them. So I did that, and when I did that, I realized what was in between the tetrahedrons. They're octahedrons. Do I have a little octahedron somewhere? No, I don't. I guess it got destroyed. The glue, while I was traveling, melted with this 108-degree heat we've been having. So I lost some of my models. But an octahedron is a pyramid with another one below it. Emphasis on the word pyramid. So I was happy to find that the pyramidal geometry was present between the tetrahedrons. Can everybody see how an octahedron is 2 pyramids base to base? If this is one point of the pyramid, then the base is here, and it's a square base. It looks rectangular because it's in perspective. And the other point is here, right? 2 pyramids base to base. There is a bunch of them together, but when I did this, I realized there was something weird. There was something weird in the middle of the metric, because the metric is called isotropic. So you would expect that it would be always in balance, that it would always be in symmetry. But there was a symmetry in the middle. I found 4 reverse tetrahedrons pointing down and rotated 180 degrees. And they didn't belong to the octahedron, and they didn't belong to the tetrahedrons that made up the outside or the metric. So there was a bunch of these, there was 4 of these tetrahedrons completely out of place, creating a symmetry in the middle of symmetry. Now I knew this had to be incomplete, because if this was the fundamental structure of the vacuum, it had to be isotropic and symmetric so that you would have perfect equilibrium. Oh, there's an octahedron. Thank you. Ooh, nice. Q-tips. Thank you. Appreciate. Q-tips with what? Honey?
Rubber cement.
Rubber cement. Here's an octahedron. And so when, yeah, that wouldn't melt as well. Oh, that's good. Because I used to do it with marshmallows, but then people would grab the marshmallows and eat them. And I lose my model. But anyway, so the isotropic vector metric had to be modified. I didn't know how. One thing I was sure of is that the universe is polarized, so that it had to be 2. Okay? Now, if you have a polarized universe, and you have 2 isotropic vector metrics, and they're mirroring each other, you have a problem. Because the two mirroring each other, base to base, don't make a sphere. Remember, fundamental axiom, the universe is generating spheres, right? So you don't have a sphere, you have an egg. And so now I had the chicken and an egg problem. And I was like, oh my God, what do I do with this? I didn't know what to do. But I knew it had to be two isotropic vector metric. I didn't know what to do with these other spaces, these other tetrahedrons in the middle, neither. And you got to realize that at that point in my evolution now, I'm finishing my ski career. I got a bunch of universal 2x4s behind the head, forcing me out, telling me you got to do this full time. You ain't gonna do this while teaching skiing. And this point, I'm still doing all this without a computer. So I'm rendering these geometries in my head, and I'm trying to figure out how they fit together. Okay, I found the octahedrons in the middle and all this, and then I'm going, okay, wait a minute, I gotta make this become a sphere. But I don't want to distort the geometry of the isotropic vector metric. It has to be tetrahedrons. So I'm like getting all frustrated about it, and I'm, okay, well finally I decided, okay, and I pushed one into the other, and I generated this in my brain. I was pushing one into the other and trying to figure out where the tetrahedrons would fall. And then that's when I realized what had happened. When you push one isotropic vector metric into the other so that you generate a perfect sphere, then the central geometry is a vector equilibrium, the only geometry in full equilibrium in all vectorial possibility. And there is no distortion because those four tetrahedrons that were in the isotropic vector matrix alone were there to accept the reverse one, so that the one isotropic vector metric was missing its better half. And when the two came together, it created equilibrium. I still get the chills from that time when I discovered this. It was like, oh my God, this is beautifully, metaphorically, and beautiful for what I'm trying to achieve. The geometry of equilibrium, the geometry of the vacuum. And I could see how the male and the females coming together generates a new point of center, a new being. Boy, at that point, I was living in my van. I had sold everything, all my ski equipment, all my stuff. I moved into a van so I could sponsor my research. And I moved down south so I wouldn't have to eat so much. And so I was doing this in my van, and I was so excited. I mean, this was better than sex. I mean, I didn't have a girlfriend at the time, And so it was just beautiful. It was metaphorically beautiful, but in the physics of what I was trying to achieve, it was exactly going in the direction I wanted it to go. And I realized that the vector equilibrium had to be fundamental to the structure of space, of the class. Why is the vector equilibrium the only geometry in full equilibrium in all vectorial possibility? Let me show you. If you have a vector going in one direction, and that vector has a certain length, we'll call the length of the vector its force. So longer it is, stronger it is, shorter it is, weaker it is. Okay? In order to get equilibrium, you would have to have a vector in the exact opposite direction with exactly the same length. But that's a weak equilibrium because you'd have to nail that vector so that it would be a perfect alignment here. Otherwise you would miss equilibrium, and any forces pushing down in any other direction would break the equilibrium. It's very precarious. So how would you increase stability? You'd probably add vectors at 90-degree angle from those. Now you increase equilibrium, right? However, the edge of your geometry has longer vectors than the vectors to the center. Because they're longer, they're stronger, and thus your geometry explodes. It doesn't work. What would you do to try to correct it? Probably add vectors at 45-degree angles from these other ones. But if you did that, then the edge vectors are shorter than the vectors to the center. The geometry implodes. You still don't have equilibrium. So what's the solution? The solution is the hexagon. Because the hexagon has edge vectors that are the exact same length as the vectors to the center. It's the only geometry that does that. So now you have equilibrium. And what does that look like in 3D? It looks like a vector equilibrium. This geometry here. Oh. Okay. Vector equilibrium. It's 8 tetrahedrons pointing inwards. Now, this can be seen as well as 4 hexagons intersecting each other. You see that? The red one on the edge, there's a blue one at the equator, and then 2 ones intersecting in the middle. Everybody see that? There's a red one on the edge, an hexagon on the edge. 4 hexagons intersecting, creating equilibrium at the center, or singularity. And note that there is 12 vectors radiating from the vector equilibrium. So there's 12 vectors radiating from the center, and there's 12 edge vectors, 24 vectors. These numbers are found in most ancient civilization texts. 12, 24, and so on are found everywhere. The 12 angels with singularity in the middle, the 12 apostles with Emmanuel in the middle, the singularity, and so on. The 24 elders in Kabbalistic tradition, and so on. So I was really amazed that I had found this, but my geometry was still out of equilibrium. Meaning, on this geometry of the 2 isotropic vector metric, the vector equilibrium in the middle had all of its octahedrons filled. That means that when the vector equilibrium is in the middle, the pyramidal structures are completed with octahedrons. But the edge octahedrons were incomplete. So I still had a symmetry. So I went back to the drawing board, back in my van, trying to, I've got this in my brain, and I'm noticing that some of the faces of the octahedrons are not covered. So it's asymmetric. So I decided I have to keep adding tetrahedrons till I gain symmetry. So I kept on adding tetrahedrons, and to cover all of the faces, I had to add 24 tetrahedrons to the ones that were already there. So this is one isotropic vector metric is 20. The other one is 20, that's 40, plus 24. 40 plus 24 was 64 tetrahedron metric. The 64 tetrahedron metric is a match to many, many things. I'm going to give you a hint. There's 64 codons that generate the 20 amino acids of your DNA structure. Okay? Now, when I found the 64 tetrahedron grid, then I realized that that was the quanta in which symmetry was present everywhere, and equilibrium was truly generated at the center. But what got me really excited is that I realized what I had built. What I had built was a fractal structure, just like the 2D fractal structure I showed you at the beginning, but this one in full 3D spherical coordinates. The only true fractal 3D spherical coordinate that you will find. Can everybody see the vector equilibrium on the inside and then the vector equilibrium on the outside? This continues to grow to infinity. And I could see that the inside vector equilibrium, its radius is exactly half the radius of the one on the outside. So the geometry grows in fractals, but not only does it grow in fractals, the fractals are perfect octaves. You see? And so I got really excited. It's like, oh my God, here it is. The structure of the vacuum. Equilibrium to infinity. Infinitely big to infinitely small. And then I noticed further that how this was constructed is constructed this way. Let me see if I can let go of some of this stuff. Actually, I'm going to leave that. I realized what I had built. I had built a matrix based on 8 star tetrahedrons, each having 8 tetrahedron in it. Okay? All coming together towards the center to generate the star, the 64 tetrahedron grid. But when it did, the 8 stars coming together, okay, here you're only going to see 6, plus the one in front, and then there's one in the back you won't see. So the 8 stars coming together generate the vector equilibrium in the middle. Why is this significant? 8 star tetrahedron is made out of 8 tetrahedron pointing outward, radiation, coming together to generate the vector equilibrium, which is 8 tetrahedron coming towards the center, generating contraction. So now, not only did I have found the geometry of equilibrium, but I had found the only fractal 3D metric, and it generated expansion and contraction. Exactly all the axioms I had placed for myself when I started this investigation of the geometry of space. I was so excited.
In his head.
I'm still excited. I was doing this in my brain. I didn't have a computer, and I confirmed it later on computers. But I was like, oh my God, this is so awesome. And then something really weird happened. I knew I had the fundamental structure of space. I knew, I was definitely seeing. Now realize, you guys, if we truly have the fundamental structure of creation, then technology that's based on this information is going to tap directly into an infinite potential of energy, infinite potential of gravity, infinite potential of rejuvenation, regeneration, and so on. You're talking serious change in our way of doing technology. So I was really excited. And then a bunch of people in England called croppies. Those are people that measure and photograph crop circles. Okay? Now, I know you guys, crop circles, There's scientific papers that were just published in peer-reviewed journals about crop circles, because many of them are not being able to be explained by people going in the fields at night and stomping around, Doug and Dave drinking moonshine and freaking everybody out. Some of them are not easily explained, and actually papers have just been published in peer-reviewed journals saying that this might be a new source of energy. But the croppies that I'm talking about decided in 1997 that if somebody was trying to talk to us through the crop circles, maybe we should talk back. So they went in the crop circles and they wrote in big letters by stomping around with their boots, what do we need to know? Good question. And the next crop circle that occurred was the largest crop circle to date at that time. And it's this one. Have we seen this somewhere? This is everything we've been talking about this morning. What do we need to know? Well, that's really nice. They give us this. They even made it in a way that's not reproducible by Doug and Dave drinking moonshine. Because all the hay is woven in a way that it makes effects of light and shadow that gives the vertices, the edges of 3D tetrahedrons. That is not easily done in the middle of the night. And so, and it was enormous. It was the largest today. It was much larger than anything previous to that. And it was interestingly situated near ancient, sacred site. And then a few weeks later, the next crop circle, a few weeks later, was another iteration of the same thing. So they were insisting on the pattern. What do we need to know? You guys get it? Look at tetrahedral fractal geometry. Right? How do you fit infinity in a finite space? Note that on these fractal curves, although there's not a boundary around the whole thing, the boundary is implied because the circles are all there of the smaller boundaries of the fractal. You guys follow this? So I was like, oh my God. Well, when I found this, I was living at my friend Gabrielle Cousin, in Arizona, and you know, he found me jumping on his couch, pulling my hair out. I got a picture of that part in the middle, and I realized what it was. It's the exact same geometry, but this one going inwards, towards infinitely small. So I was, oh my God, this is actually telling us everything we need to know about the structure of reality, the structure, the physics of creation. And that's according to my theory. I was mind blown. But then on top of it, they made it so nice that you could actually overlay the 14 octahedron cavities that are generated by the 64 tetrahedron grid right on top of it, and you get a very nice match. So, you know, and then since then, it's been going berserk. There's been 64 tetrahedron crop circles occurring. Look at the precision. Again, right beside an ancient site. Stone site with an enormous stone that was placed on top of another. And sure enough, when you overlay the 64 tetrahedron grid, you get a perfect match. This is not trivial. Okay? When you continue to explore the crop circles, this one is really interesting. It was thought to be by one of the famous psychics the most important crop circle ever to occur. And because it's really simple, everybody went, huh? There's other crop circle much more interesting. But in fact, if you look carefully, that crop circle is a 2D representation of a 3D vector equilibrium. And in this crop circle, it gives you singularity in the middle, and it tells you that each tetrahedron generates the sphere, the radiative side of the equation. But then, if you take that sphere around each tetrahedron and you add the other ones of the other tetrahedrons, you get this symbol, the seed of life, known as the seed of life or popularized as the seed of life. That is a symbol that is found in many, many ancient civilization walls as well. And then they give you a crop circle to tell you you've decoded it right. And they insist. Here is your intersecting spheres. Note torque, rotation. Do you realize that current Einstein field equation does not accommodate for torque? What they did is that they eliminated torque by attaching the observer to the rotating object. So that they wouldn't have to deal with Coriolis effect and torque. Well, if you do that, there's a good chance you're going to end up with 98% the mass of the universe missing, which is exactly what occurs in current cosmology. But instead of revising their approach to energy and torque and so on, they invented a new kind of matter. They call it dark matter. And they just plugged it in to the equation to make it work. Some kind of dark matter that doesn't radiate, that nobody can detect. It's convenient. Your equations are missing 98% of the mass out there, and instead of revising your equations, you just plug in some dark matter. This is not what I think of good physics. But if you look at galaxies and so on, imagine all the torque you would need to orbit a galaxy, billions of stars. You're talking about a lot of energy. So they give us a little bit of an idea about the rotation here and the Coriolis effect. But as well, you know, in case we were confused, they made sure we realized that it's all in a fractal structure. You see, it's all there. It's just amazing. Okay, this is a part of the presentation. Are you guys all doing okay? I'm just going to finish this section, and then we'll go. How are we doing? 12:30. Actually, if you guys want to take a little break and go to the washroom and all this, we'll do 10 minutes, or actually, let's do 5 minutes. Be back here at 12:35, okay? And we'll reconvene and we'll do another section and then do lunch. This next section is really exciting. It's a lot of fun. Okay. Have a good break. Thank you.
What do you think?
Well, we're going to go a little longer and do this section. This section is quite amazing. And you might not get right away the relationship to this research, but you will get it in this afternoon session. So we were talking about crop circles. And, you know, all these, you know, esoteric crop circles that are occurring. And if you don't have a base in what we've discussed earlier, it doesn't necessarily make sense. It's like, oh wow, you know, a bunch of really cool geometries in the field, you see? But with what we have come to in our conclusion, with what the logic we've been following since this morning, then all of a sudden these crop circles have a whole new meaning. They are talking about something very, very important, very fundamental to reality. And you know, you imagine that you were an advanced species that had the capacity to travel across the universe. And you showed up on this planet, you know. You found this planet and you know, you're basically like studying the planet a little bit before you land, you know. And, you know, you kind of tap into the radio waves and the TV, and, you know, you look at the TV and you watch a football game with, you know, all these people bumping into each other, running after this piece of skin, and, you know, all the rest of the people, thousands of people getting drunk, eating hot dogs, you know, and doing the wave. You might find that when you turn around and you say, okay, who's volunteering to go on the surface, you'd have a hard time finding volunteers. You know? You might find, and I don't have anything against football, but you know, with all the people shooting at each other, you'd probably say, well, you know, it's not a good idea to land on this planet right away. We got to wait till these people have a little bit more understanding of the way the universe functions and how it works together, and how the universe actually works in collaboration with all points, not in destructive and with all points. And so, you know, there's lots to be said about that. The concept that the universe always goes towards further disorder is violated by simple observation. The laws of entropy are violated by simple observation, and I'm gonna go through that a little bit more this afternoon. So remind me, but you know, we don't have time to go through that right now. But basically, there's evidence, including your own existence. If you take your DNA and you put it end to end, well, you'll find, first of all, that in one cell, there is 6 feet of DNA. This is from the Genome Project. And if you took the 6 feet of DNA that's in one cell and then put all the other 6 feet of all the other cells in your human body right now, you could wrap your DNA 5 million times around the world. That's how much DNA there is in you right now for you to exist. That is not a sign of disorder. That is a sign of extreme amount of order, extreme amount of organization and complexity. So maybe, you know, if you were one of those species that found one of these planets that hasn't figured out the organization and the complexity and the support that the universe generates in order for you to be there, you'd probably try to give them a bunch of drawings in their crops and stuff, try to educate those people before you try landing on the White House lawn. Right? Because you probably won't find no volunteers to go and get shot. Right? So, but did they only talk to us about the geometry of the vacuum, the geometry of reality? No, they didn't. They actually talked to us directly in binary code. We have been contacted. 2 summers ago, this crop circle occurred. It's the only crop circle that ever made it to the mainstream media news all around the world. I had friends calling me from the eastern U.S. telling me, I just saw a crop circle on the 5 o'clock news. The reason why this crop circle made it to the 5 o'clock news around the world is because it occurred in the middle of a rainstorm. It rained all night. Cats and dogs. And in the morning, this crop circle was there in this field. The largest crop circle ever to occur. 409 circles. It's enormous. And basically, it told the world crop circles are not just hoax. There is crop circles that are not hoaxes. Well, the next crop circle about after this one did not make the mainstream news around the world, most likely because it was too shocking. The next crop circle that occurred was a reply to this. In 1972, Carl Sagan and other physicists, astrophysicists, figured that we had just finished building the Arecibo radio telescope, the largest radio telescope on Earth, and we had the opportunity to send a very strong signal into the universe that could reach a faraway planet one day. And maybe they would decode the signal and then send the signal back And then it would reach our planet one day. And we would know that there's living entities out there. But that would take a few thousand years. They still decided to send a signal to give a chance to our grandchildren to get, a chance to have a talk with other beings out there. So they figured out a way to send a signal that would be the easiest for others to decode. They use a binary code of ones and zeros, just like a computer, and that can be transferred to a punch card, just like a computer punch card. Okay? And what does it say? It says, we're made out of carbon. This is our chart of elements. This is our DNA. We have a small head, big body. We live on the third planet from our sun. And you see, that's the sun, that's the third planet we live on. And this is the Arecibo radio telescope we're sending this with. This is the technology we're sending this with, a radio telescope. So they sent it in 1972, and 2 summers ago, across a radio telescope commonly hired by SETI to listen for a reply, came 2 crop circles, one being a reply to the Arecibo radio telescope signal, and the other one being a nice little mugshot. Did you hear about that crop circle? No. When SETI was asked about this, SETI is the NASA, search for extraterrestrial life. They're listening with huge radio telescope to see if they can hear something out there that would be life on another planet. One day I'm going to make a comic strip with a huge radio telescope, a SETI guy with the big earmuffs, listening, and in the background, back here, a little UFO. When they saw this, they said, well, it's got to be a hoax. Because if they wanted to talk to us, they wouldn't have sent a crop circle. The radio telescope was right beside it. Why didn't they just send a radio signal? Well, my reply to that is, if they would have sent a radio signal, you and I would never have heard about it. Maybe they wanted to talk to all of the people of the planet, not just a few agencies, right? So instead, they sent instead of a radio signal, they put the crop circles reply directly across from the radio telescope. And you got to realize that here you have a governmental installation that has infrared cameras, guards, and all of this. Nobody saw nothing. Right? And it's not like Doug and Dave can go in that field and do that all night and nobody noticed. And then when you look closely, the woven patterns of the hay are not reproducible readily in the middle of the night stomping around. The actual mugshot is an incredible pattern that generates a negative image of a picture. And you can tell that that being has large eyes, a small nose, a small mouth. And the reply says, this is what we sent, this is what came back. It says, we are carbon and silica. Our table of elements is very similar. It says we have a 3-strand DNA structure. it says we have a big head and a small body. We live on 3 of the planets of our solar system. The third one has 4 moons. And this is the technology we're sending this way. Now, this is not subject to interpretation. This is a binary code. They're talking to us directly. Okay? Now, when I saw this, I got really excited because I'm like, oh my God, they give us a blueprint of their technology. It's right there on the bottom. I'm like, whoa, what is this? Well, the resolution is really poor, so you can't tell what the heck it is. Well, they thought about that. They were nice about that. Because a year prior to this reply to the Arecibo message, in the exact same field, a year to the date of the reply, prior to the reply, to the date, this crop circle occurred, which is exactly what's at the bottom of the reply. Just to make sure we had a high resolution blueprint of how they're using their technology. Here's your radio telescope. It's the exact same installation. You can see here the fence, you know, and all the security equipment. And this is right across from it. And that's what it looks like. Fractal tetrahedron geometry spheres. Everything we've been discussing this morning. So here, they're telling us directly, and notice, you know, that the sphere are fractalizing to smaller and smaller outside and fractalizing towards singularity on the inside. Now, that's just incredible. And that's not the only thing they've been contacting us with. A year after the Arecibo message reply, to the date, so this was a year prior, right? So the Arecibo message came in. At the bottom of the Arecibo message, there was a technology which they had put a year prior, right? Now we're going to go a year after. So last summer, midsummer, a crop circle occurred exactly the same date, but a year later. And this one was an enormous crop circle. Almost 2 football field long. Again, across a large installation communication antenna, which has security all around it. Right across road, this is a huge crop circle. Can everybody see what it is? It's the side view of an alien head with a big eye, the nose, the mouth. Can everybody see that?
Not fully. Oh, yeah.
Can you see it better here? See his eye, his nose, his mouth. And look up here in front. He's got a hand like this. Right? It's the other hand. Right? Like this. And he's holding on to a CD. That's his thumb here, and that's his hand. Okay? He's holding on to a CD. They figured those guys are at CD technology level. We'll burn them one. So they burned us a CD, and sure enough, on the CD is a string of a binary code. what happens when you play that CD? Well, that binary code was decoded, and here's what it says. Be aware of false gifts, they're broken promises. This was last summer. Have we seen broken promises this year? Oh my God. This is very interesting. Much pain, but still time. Certainly a message of hope for all the people that have been working towards a new way of doing things on this planet. Believe there is good out there. And then we oppose deception. And the and has a bell sound. This is an ASCII code, so there's a bell sound typically to end a transmission. So I haven't had time to work on this so much because I'm publishing a unified field theory with a lot of math and a lot of work in it. And so I haven't had time to work on this, but I am convinced that there is an underlying code as well in this. Because these capitalizations are actually part of the code. So if you only read the words that are capitalized, you have false, broken promises, pain, believe, good, OP, deception. I don't know what OP deception is. Could be other people, it could be many things. But go ahead.
Are the capitals at the beginning of the sentences part of the code?
Yes, they are.
How about the office of the president?
Office of the President. The Office of President deception. We definitely have seen this year.
Does the bell sound have a certain frequency?
I don't think it does because it's just an ASCII code, you know, that gives a bell sound. So I don't think it has a specific frequency to it. So this is a direct communication, my friend. Go ahead.
He kept saying a date that they did this one day, saying next year, the same date, next year, the same date. You know what date that is?
Well, it's August 15th, I believe. I'm not sure on that. You might have to verify. And I've been going on the net this year to see the crop circles of August, and the page is not updated past the 10th or the 11th. So I'm anxiously waiting to see if there's been another message this year. Direct binary message. There's been many crop circles
But
this year.
usually, apparently, August 15 is always close to this radio telescope.
I'm sorry?
Is this close to radio telescope?
Well, it's in England. The two that we saw, the two first one were right beside the radio telescope. The third one is further from the radio telescope, but then again, it's right beside a huge repeater antenna, which implies communication. So here, we're being talked to directly. They are getting closer and closer to contact. We're going to see this afternoon a little bit more of the influence that other species in our galaxy may have had on our planet early in its evolution, and how that relates to our current physics, and how that relates to the physics that I'm presenting to you today. Because there's a direct relationship. And it has to do with some of the monuments that are found all around the earth. So when you look at this, there is crop circles all around the world that are telling us about this structure of the vacuum. But when you look at nature, see, the proof of the pudding is that in this case, all of nature is included. Because, you see, if you take Einstein's field equations, for instance, there is no human being that live in that world. There is nothing in Einstein's field equations that describe how you got here. Okay? You can't put human beings in there. If you look at quantum equations for subatomic particles, there is nothing in that world in which you exist, neither. It's all probabilities. But if you have a unified field theory, then it should include all of the biological resolution. Okay? Well, when you look at biology, when you look at nature, what do you see? You see highly organized systems that generate fractal structures everywhere. Where is the fractal coming from? Look at the branch of a tree. They're all fractal structures. Look at the way the grass grows. They're all fractal structures. The way plants grow, the nervous system of your body, the veins of your body, all fractals. All very specific fractals that obey actually the phi ratio, 1.618. Always 1.618, smaller and smaller or bigger and bigger. Just like your finger. The end of your finger is 1.618 smaller than the middle part, and the middle part is 1.618 bigger than smaller than the third part. And your finger compared to your hand is 1.618 smaller, and your hand to your forearm is 1.618, and again, your whole body. All fractal structures everywhere in nature. That's the proof of the pudding. Actually, that fractal behavior of nature, according to this theory, emerged directly from the structure of the vacuum. The vacuum directs reality, and reality portrays the structure of the vacuum. So when you look at nature, you can see the vacuum geometry. And in such a theory, everything is included, including you. So then it is a fully unified theory. We're going to finish on this. We're going to just touch on it as we go. This is a presentation I did to the APS, the largest physics community on Earth. And I showed here in a scaling law, hello, I showed in a scaling law that if you take all of the objects in the universe and you plot their radius against their frequency, okay, these objects all fall on a straight line across the graph. Okay? all of these objects obeying the Karl Schwarzschild condition of a black hole. Okay? Let me explain this, what it means. Because it looks complex, but it's not that complex. This is the universal scale, our universe. We have an approximate idea of its radius if it's a closed universe. If you look at that, the mass inside the universe exceeds the escape velocity of light. That means if you shine a light in one direction, you know how Einstein discovered that the electromagnetic field can get bent by the gravitational forces, the curvature of space-time? That light will bend around one star, bend around the other star, bend around the other star, bend around the other star, and come right back. It will not escape our universe because there's too much mass in it. That means we live inside a black hole. Let me reiterate that. We live inside a black hole. That's why when you look up in the sky at night, it's black. Because light is contracting in the vacuum towards singularity. Everything inside that black hole is smaller black holes. But these smaller black holes you are outside of. This is a quasar, very, very large. This is a galactic center. This is our sun. This is an atom. And this is a subatomic particle, the Big Bang, 10 to the minus 33, the Planck's length. Note that the atom and subatomic particle are included. Current physics is divided between quantum theory, which is subatomic particle and atomic particle, and cosmology, which is relativistic equation for large objects. Here we show a direct relationship of all these objects together. No division. If all of these objects are considered different scales black holes, this is called a scaling law. This is what I'm just about to publish in November. It's under peer review right now, and so far the peer review is excellent. We're having fun yet? So now you can see that if you're in a universe that's a black hole, the smaller black hole in that universe, you're on the outside of, so they look like white holes. They radiate. You see the radiating side of the event horizon. It looks like a star, it looks like a planet, it looks like an atom, it looks like a subatomic particle. Do you guys see that? The white hole and the black hole are not two different objects. They're inside each other. And it's a feed between the gravitational field and the electromagnetic field. Radiation generates curvature in space, which generates radiation, and that generates an open feedback. And what's an open feedback? It's a fractal. That's exactly what a fractal is an equation that's reiter and reiter and reiter, and it generates an open feedback. Everybody sees this? Everything you're looking at is different scale black holes, including all the atoms that you're made of. We don't see any evidence of entropy and death. All we see is evidence of mini black holes disorganizing and reorganizing, or actually changing levels of organization. When you die, not one of your atoms will ever disappear. They just go from one level of organization to another. They go from one scale to another. Now I'm telling you that your atoms are mini black holes. Is that crazy? Actually not. Some of the largest, most comprehensive unification theory that are trying to be worked out now, and are incorrect because they're missing the fractal component, by Stephen Hawking, for instance, describe all subatomic particles as mini black hole, and the Hadron Collider that's being built in Geneva that I mentioned earlier is being built to search for these mini white hole black holes for subatomic particles. One thing that's really exciting that I discovered lately is that I'm telling you that the atoms that makes up your cells are mini black holes. Well, that's true. But another resolution is the cell itself. When you look at the surface of a cell, a biological cell, it has a grid on it. It has a mesh on it that holds the event horizon of the cell, that holds the membrane of the cell together. That is called lipoprotein. The rate of oscillation in hertz of the lipoprotein on the surface of a cell is 10 to the 11 hertz. That's 10 with 11 zeros hertz. That's how fast it vibrates, the cell. If you plot the cell at 10 to the 11 hertz and plot the radius of that cell, then you end up in the exact middle of the graph. And you have all of the biological resolution right there in the middle of the graph. And I'm not publishing this with this first publication of this paper because it's a little too esoteric. You don't want to freak them out all at once, you know? It's bad enough, you know, that you're telling them everything is a black hole. But the cell actually, the cell biology, the biological resolution actually obeys the Schwarzschild condition of a black hole because it generates so much energy. 10 to the 11 is a huge number. The other thing that confirms that this scaling law is correct is that when you look at the distances between each of the data points on the scale, oh, by the way, you know, these should fall everywhere if the universe was random, right? And they don't. They all fall on a very linear progression from universal size to atomic size. Now, if you look at the differences, if you look at the length between the data points, interestingly, when you subtract the length from each other, you get the phi ratio on that big of a scale. The exact ratio that you find everywhere in nature. The exact ratio that Kepler used to describe the scaling law for our solar system. That scaling law that Kepler came up with by embedding geometries together, which is a crazy idea. It's like, oh, I'm going to embed geometries together and figure out all the orbits of the solar system out of it. It worked. His solution is still the most accurate solution at 99.9% accuracy. And it uses the phi ratio. Well, this is like Kepler's scaling law, except it's for the whole universe and everything in it. And it generates the phi ratio, which is the phi ratio we see everything, everywhere in nature. So you know you've got it right. You guys all followed this? Now you start to see yourself as a scale, as a resolution in an infinite scale of space. You are the event horizon, you are the boundary between infinitely big and infinitely small. Go ahead.
Does biological transmutation of elements fit into this?
The question is, biological transmutation of elements fit into this? It does, because if everything is a black hole at different scale, you should be able to move the scale. If you understand that and you understand the geometry under which that happens, you should be able to move the resolution up and down the scale. And by doing so, you would change the elements. So it is a key component to eventually being able to change one element into another in a laboratory. And we'll see tonight and this afternoon how the ancient alchemist knowledge is directly related to this, and how the geometry of the vacuum function. That's why the alchemists had all this geometry embedded in their knowledge. So this is extremely significant, this scaling law, and it's just about to get published. And we're publishing it first in a very broad peer-reviewed journal, so that we can publish it as a whole with all the writing, because it's fairly long. But as well, we're publishing the solutions, the mathematical solution, in various mathematical journals, and I'm hoping that I'm sure that it's going to be ignored largely at first, because that's always the way things go. But eventually, it will get noticed, because the solutions are extremely accurate and they work for unification. And this afternoon, we're going to see more of what that means, what is the topology of how that works, and how that relates to ancient civilization. So to finish on this before we go to lunch, this geometry then, the geometry of the collapse, generates all of the scales of the black hole dynamics, each boundary being one of the resolution of the fractal structure, from universal size right down to subatomic particle size. And this geometry is what dictates where the structure occurs, where the boundary occurs. Infinite boundaries within boundaries. Well, that actually happens in a human body. The cells of a human body divide exactly that way as well. So not only does the cell obey the Schwarzschild condition of a black hole, but the cells, I have a little movie I'm going to show you on this. The cells actually self-organize in the very specific geometry of the structure of the vacuum and generates all of the complexity of a human being or anything else that it's building. Let me see if I can find it. Cell division. Here it is. Here's the cell dividing, generating perfect tetrahedrons. See? If the first cell is divided in two, the first cell divides in two, makes two cells, right? And then as you go, these two cells divides in two again, that makes four cells. The four cells don't make a cube, they make a perfect tetrahedron. You see? And each of these cells will divide again, making another set of four, and these four will go in between and make the reverse tetrahedron. And they'll continue to grow from 4 to 8 to 16 to 32 to 64. And it will not start to differentiate the cells until it gets to 64. It will say, you know, T cells are fundamental cells until it gets to 64. And then at 64, then it starts to make brain cells, heart cells, liver cells, and all sorts of other cells. So you all went through this very specific geometry to get here. You are an extension of space looking back at itself. That's the feedback of reality. That's what generates reality. You, the universe, experiencing itself, learning about itself. And that feedback between the internal and the external and the internal and the external is what drives the dynamics of all of the forces of the universe, which reduces in this view to only two forces, gravity and electromagnetism, the feedback between the two. No need for the strong and weak force anymore. Why? Because if you take this view, then subatomic particles are mini white hole black holes. This is funny, and I'm going to finish on this. Just so you know, quantum physics is bunk. Okay. Why? Because in the late 1800s, we figured out that atoms had electrons. When we discovered the electron, this crazy thing, this crazy little electron, kept on going around in circles around the nuclei of an atom. You guys are doing okay? I'm going to finish on this before we go to lunch. This electron didn't stop spinning. If you take current conservation of energy law, they're called natural law. They're the laws that were written by Newton. Okay? The laws of entropy. the electron should radiate all its energy within seconds, milliseconds after the Big Bang, crash onto the nuclei, and all atoms should have been alienated. There should be no atoms in existence. So when they found the electron, negatively charged electron spinning around a positively charged nuclei, and it didn't slow down, actually the electron spins at near the speed of light, 99.999% the speed of light. Ain't slowing down neither. We haven't seen any of these electrons slow down. So that was a large conceptual problem when they discovered this. Well, instead of re-examining Newton's laws, they invented a new type of physics. They called it quantum physics. They said the first axiom of quantum physics is we don't care about causation. That's the first axiom of quantum physics. That means we don't care what's making this thing spin. We're going to avoid that whole problem by saying we don't care about it. And if we're asked about it, we're going to say go and see your priest or go to church or whatever. We don't answer that question. And they started from there and they said, okay, at this electron energy level, we'll call it quanta. And then we'll quantize for the next electron level and next. And they wrote the math, and so that they could predict the first electron shell, the hydrogen atom, and then they approximated all the other atoms out of it. Oh my God. Never explaining why this thing is spinning and ain't slowing down. Okay. We'll see this afternoon why, well, we'll see why this is a problem. Well, actually, we'll see it now because otherwise this afternoon you won't be able to remember. But basically, what happens is that look at this statement. Newton's laws are of conservation of energy. If a system does not interact with its environment in any way, that's how they all start, then certain mechanical properties of the system cannot change. They are sometimes called constant of motion. These quantities are said to be conserved, and the conservation laws which result can be considered to be the most fundamental principle of mechanics. They're called natural laws. In mechanics, examples of conserved quantities are energy, momentum, and angular momentum. These conservation laws are exact for an isolated system. All of our current physics is based on this. Nobody took the time to ask, what the heck is an isolated system? Open a physics book and look up isolated system. An isolated system implies a collection of matter which does not interact with the rest of the universe at all. And as far as we know, there are really no such system. So now you have all our natural laws based on something that is not found in nature. That is a big problem. And that is the reason why we haven't understood the electron and the atom. Because the electron and the atom and everything else in the universe all interrelate. No such thing as isolated system. There is no shield against gravity, and the electromagnetic force is infinite in range. But in order to focus on basic principles, it is useful, that's debatable, to postulate such a system to clarify the nature of physical laws. That's debatable. In particular, the conservation laws can be postulated to be exact when referring to an isolated system which was just said not to exist. That is circular thinking. Now that's where fractals come to the rescue. Because in a fractal, every system is related to all other systems. And when you write the math, when you write the physics, you're then taking in consideration all of the rest of the components that are occurring in order for that system to exist. The electron cloud and the atom is continuous because it's continuously interacting with the rest of the universe. It radiates energy, and that energy eventually curves back into it to generate gravitation, and out and in and out. And when you start to see it that way, then you can do something that's really nifty. You can look at the subatomic particle. See, the other thing quantum physics did is when they found the nuclei of the atom, now they were deep in doo-doo already, right? When they found the nuclei of the atom, they noticed that the protons were all positively charged and all stuck together in a teeny bitty thing in the middle of the atom. They calculate, you know, when you take two magnets and you try to push them towards each other, right? How they push against, right? Now they tried to calculate how much force organization theory, not chaos theory. Because basically what chaos theory proves is that whenever you think it's chaotic and it's random, you can always find a higher point of perspective in which you find organization. But since that would be going against the concept that the universe is going towards further entropy and that everything is always going towards further disorder, they called it chaos theory, just to confuse everybody. But chaos theory is really a theory that proves that there's no such thing as chaos, but that there is only different levels of organization. I was looking for some CD. Where we were, so we were finding that the structure, we're just going to do a little quick, oh yes, go ahead.
I had a question about, one of the last things you said was about strong force and actually the gravitation in the black hole. Can you repeat that?
Okay, what I was saying is that when quantum physicists found that the protons were all stuck together in the middle of the atom, they calculated how positively charged particles could be that close together. They would have to have some huge force holding them together because they have a tendency to move away from each other because they're all positively charged. They calculated how much force it would take to hold them together, and they called that force the strong force. And basically invented a whole brand new force, which they didn't say where the force was coming from. You remember? Because quantum physics says we don't care about causation, we can invent anything we want. So they just invented a new force, they didn't say where it came from. Actually, when they found the quarks, they found that the quarks had to be squished together as well. So they made the strong force the color force at the quarks level, just inventing forces. And they basically, what I'm saying is that if you consider quarks and protons as small mini black holes, and then you calculate, you know, how black holes would have a gravitational field. If you calculate the gravitational field for these mini black holes, then the gravity that these mini black holes generate is strong enough to hold the particles together. And you don't need no strong force or color force, basically, that were just pure inventions of modern physics. Do you see what I'm saying? So all of a sudden, you see, one of the problems in current physics is they can't relate gravity to the strong and weak force at the atomic level. But that's because they invented forces that don't belong, you know? And you just got to re-examine how you're looking at these subatomic particles with the force you already have, which is gravity and electromagnetism, and then all of a sudden it all starts to make sense. You see? Yeah. So basically, this morning we saw that there was very fundamental errors in our concepts of dimensions, and then we saw that these, these concepts can be described and corrected. These concepts can be corrected by using a fractal analogy. And I want to mention that the fractal analogy is much more than just an analogy. It is a whole new way of writing physics, which accommodates for singularity. Basically, the largest error in current physics is they can't deal with singularity, so they make it like it's not there. And so basically, for instance, Bohm was a collaborator, physicist that collaborated with Einstein, and he tried, Einstein's field equation he wrote to try to unify physics. And he was trying to find a unification theory from the beginning, and he never succeeded before he died. But Bohm was on his case saying it's got to be holograms. It's got to have to do with holograms where every part contains all information and so on. And Einstein was wanting to use hologram, but holograms are not mathematically applicable. It's a nice analogy, but there's no mathematics that are useful in hologram that you can apply to the field equations. However, fractals are mathematical equations that can be applied to physics. The other thing that's amazing about fractals is that a fractal equation is a reiteration of an equation that is deterministic, meaning the equation itself is deterministic, a circle and a triangle, right? But when you reiterate it, it becomes an open feedback to infinity. So it has a completely non-linear, non-deterministic output, right? So from a very deterministic equation, you get a complex, nonlinear output. And so you're accounting for both sides of the universe, the deterministic part and the non-deterministic part. So we saw that we can solve these dimension problems by describing dimensions at different resolution of a fractal. We saw that the universe is most likely expanding and contracting at the same time, and that the contractive part of the universe would have to have a very specific collapsing geometry, which is related to a tetrahedral grid that eventually generates 64 tetrahedron as you find or research the perfect geometry for a collapsing equilibrium, which is the 64 tetrahedron grid, which is generated from 8 expanding Star of David coming together, generating the vector equilibrium at the middle, right? And then we saw that each of the tetrahedrons generating the spheres create this incredible geometry of the flower or seed of light that we see emerging at all levels. Including the way cells develop in a woman's womb. Note as well that we all came out, like good evidence that the universe is a fractal. Nobody seems to notice, but we all come out of other people. That is a pretty good evidence of fractals being, part of the foundation of creation, right? We all came out of our mothers, and when we look at it, we could say that the tetrahedron in the sphere is actually reproduced in the creation of new human beings. You see, because you have, a penis, a vector, and a vagina, a sphere, and the penis crosses the event horizon of the sphere. And then it sends another little vector, sperm, out, and that little vector crosses the event horizon of the cell of the egg, right? And then the egg crosses the event horizon of the uterus and goes in the placenta and grows and makes a sphere, right? And then the sphere, inside the sphere is the vectors of the legs and the arms and all this, and then eventually that vector moves out and crosses the event horizon of the mother. You see how that, evolves? And then eventually, as you die, you cross the event horizon of your own atoms, and so on. And I thought that was interesting. But as well, all of life emerges out of water. And the water molecule, H2O, is a tetrahedron. You see? So the water molecule, and so is the silica molecule, are like the transducer for the vacuum information to move the information through into this level of the resolution of reality. Why do I think that water is a transducer? Well, by observation, everything emerges out of water, and if the vacuum geometry is tetrahedral, you would assume that the vehicle that brings the vacuum geometry information through would have to be tetrahedral. It would have to match, and it does. But what's really interesting is that as it does that, water is the only element we know of that expands when it cools and contracts when it warms. So it has a completely reverse thermodynamic structure. And that's the link across the event horizon. It has a thermodynamic link because the vacuum goes towards absolute zero and the electromagnetic field goes towards heat. So, there was something else on water I was going to say, but I just lost it. Well, in any case, from the water molecule, the water then is an extremely good example of the dynamics of space creating reality. Let's imagine a water droplet falling from the sky. It's a sphere falling through space. Now, as the sphere cools down, it reverts back to its smallest dynamic. It contracts to its smaller dynamic, to its most stable dynamics. And what does it do? It makes a snowflake, right? The snowflake is an hexagonal vector equilibrium, and it's fractal. There's millions of different snowflakes, and all of them are hexagonal in nature, and all of them shows evidence of fractals. Frost on the window will show you that. And so, are you guys following this? So we had concluded that the geometry of the field involved, this is the surface of the cell that is oscillating at 10 to the 11 hertz. This, I'm showing relationship between cells and galaxies. So we had concluded that the tetrahedron grid and the octahedron at the center generating the vector equilibrium in the 64 tetrahedron pattern is the foundation of the collapsing side, and that the radiative side that results is the sphere. Okay? We see the sphere. We see everything that's convex, right? What we don't see is the part that's contracting, everything that's concave, right? So now, when you look at it, the sphere intersects, making these petal lobe-like structures. You see? That's the intersection of the spheres. If there's a sphere around each tetrahedron, right? Remember, you put a sphere around each tetrahedron. Now they intersect, creating these lobe structures, and these lobes, these petals, go directly to the apex of the octahedron cavity between the tetrahedrons. That's why in this model I have red beads in the middle. These red beads in the middle are the intersection of the spheres if I had a sphere around each tetrahedron. It's interesting that the petals don't fall anywhere in the geometry. They fall exactly at the apex, at the vertices of the octahedron in the middle. And so, when you look, so I was studying this, and I was, I was thinking about these lobes, and I'm like, well, what are these petals? What does that have to do with anything, in physics? Well, at the same time as I was studying this, I was trying to figure out the physics, of waveforms. And I was really studying hard, trying to understand waves and to understand physics in terms of waves and so on. And, I was getting a lot of headaches. I couldn't figure out what the heck was a wave. And the reason why I couldn't figure out what the heck was a wave is that when I'm the type that observed nature. And so I would observe nature. And in nature, I didn't see anything going up and down like this. And the physics book kept on saying, very basically, that everything was a wave. Right? And it's like, well, if everything is a wave, why isn't everything moving up and down like this? Traveling through space up and down like this. And, I couldn't figure it out. I was like, oh my God, what is this wave thing? And it was giving me a headache. And I was like studying for months, trying to figure out the wave. And finally I got frustrated and I thought, well, I'm going to go back to point zero. Forget all these physics books. And I just hopped in my van, went to a high lake in Canada. I lived in Canada at the time. And I went to one of those turquoise lake in the high mountains of British Columbia, which has, which is really, really flat. And I grabbed a rock and I threw it in the lake. And I'm like, I'm going to start with point zero. What the heck is a wave, right? So I threw it in the lake, and the rock hit the surface tension of the water, and sure enough, the waves came off, and I could see that if you bisected the waves, you would get this up and down motion of a sine wave. But something was not quite right. If you have this up and down motion of the wave, it's only a result of that rock hitting the surface tension of the water and pushing the molecules away. So you have to account for that force too, of the rock going through the water. So if you account for the causation of the wave and the wave, then you get a different model. You get a model of more of a cone, because the rock is sinking and the wave is going out. And that's when it hit me. Oh my God. I realized what had happened. This is this two-dimensional problem again. Guess what? Our universe is not on the surface screen of an oscilloscope. Our universe is in spherical coordinates out here, okay? And so what happened is that because physicists and mathematicians are really not good in dealing with rotation and angular momentum, torque and Coriolis effect and all this, they flattened the wave. They made it like this. So what I did when I had this elimination of the cone, I went to the side of the lake on the sand and I drew a wave with a stick, but then I put a line through it like this, and I realized that the wave is actually a 3D vortex. Can everybody see that? And I was like, oh my God, they flattened the wave. That's why I'm confused. Nothing in the universe goes up and down like this. Everything in the universe orbits and rotates. This is when this is one of the reasons that Einstein field equations are not complete. It's because the torque and the Coriolis effect that's resulting from rotation is eliminated by attaching the frame of reference to the rotation of an object. when they calculate the forces involved in a black hole that's rotating, they attach themselves to the black hole so that they're rotating at the exact same rate so they don't have to deal with torque. Go ahead.
Does rotation have something to do with time and the way time's interacted with?
Yeah, and we're going to see that in a minute. So, imagine that there is, I'll give you a simple example. Imagine that there's an electrical motor turning in front of you, and there's a shaft, and you're going to try to grab that shaft, right? Now, if you grab that shaft and you're not moving with it, you're going to get heat, you're going to get torque, you're going to get all sorts of effects, right? Thermodynamic also. Your hand is going to start shredding, right? Okay, but if you turn with the shaft, then there's no force. You see? Now that's a big difference. Okay, if you're calculating things where things are turning with, if the observer is turning with the thing, then you're going to miss a lot of forces. Imagine, for instance, calculating the forces that are going on in a galaxy. 300 billion stars orbiting, right? But instead of being an observer looking at the object orbit, you're attaching yourself to it, then there's not going to be any forces. That's a big omission in current physics. But what happened there is that I realized that the waveform is not a thing that goes up and down like this, but actually a thing that goes in orbit. And when you look at it that way, then the wave frequency, the wave amplitude, and the wavelength are all a result of angular momentum, rotation. You see? That not being accounted for. When you look at the sun and you imagine the electromagnetic field of the sun coming towards you, typically you're imagining something coming towards you like this, right? But actually it's coming towards you like this, right? And so I was excited about that. I'm like, oh my God, okay, this works. It's a vortex. And then I was leaning back on the sand, and I was looking at the sun go behind the mountains as it was setting. And I thought, isn't it cool how we always think the sun is like setting, but actually it's the earth that's turning? And as I thought that, I had another illumination. Oh, mechanically. And I thought, wait a minute. We've all been taught in our current understanding that the sun is here in the center of our solar system, right? Since Galileo and Copernicus. And that the planets do something like this, right? Is this true? No. That actually has nothing to do with the dynamics of our solar system. Although this is taught to all children at school. Even in my school, there was like one of those little devices, you know, that you turn the little thing on the bottom and the planets go around the sun. I don't know if you had those, but I had those in my school. And it's actually completely incorrect. Here's our closed, isolated system biting us in the butt again. Because the sun is moving 200 kilometers per second. And the planets are following at the equator of the sun, generating a huge vortex that has nothing to do with planets coming back onto themselves over and over again. See how different that view is? just from not going with a closed system, right? And I realized it's all vortices. Now, when you look at it, you could say this is 2000, this is 2001, this is 2002, and so on, right? Like the Earth. Well, this distance has nothing to do with the same point in space-time. After a year of rotation around the sun, the Earth is millions and millions of miles away from where it was last year. Do you see how that starts to open your mind, open your consciousness to what's really occurring?
I mean, I'm still 1 year old.
For me?
I mean, I'm still 1 year old.
What do you mean?
Well, there's no birthday, so you never get back to the
Yeah, there. Well, you know, the birthday. Actually, there is still a birthday, and that's when you were 2 and you were 3, because you were changed. In fact, if the Earth came back onto the same space-time coordinates, then you wouldn't change. It would be the same year. Every year it would get really boring. So, like Groundhog Year, you know? And so that I realized why every moment is a different moment. Every moment is a different moment because we're moving through the geometry of space-time. And every movement through, every point on that spiral is a different point, is in a different relationship to everything else.
Could you explain the Coriolis effect and how that fits into this?
Well, the Coriolis effect, that's a little more complex. I'm going to explain the Coriolis effect later on. It's going to be easier with the graph on the computer. Go ahead.
Well, what you're showing is that time is actually a spiral, not a circle.
That's right.
So we've miscalculated time as well.
Yeah,
Our
it's not.
understanding of time.
That's right. Time is not, and we're going to discuss that in a little minute here. Here, time is definitely, this is like a concept of linear time, you know, but plotted over a spiral instead of a line, okay? Because that's the true dynamics of our planet. Why is this important? Well, in physics, it has its part, and we're going to see that in a minute. But I've used that in psychology. That is that when you look at this, you can say that in each point of time on the planet, you have left an imprint on the space-time structure where that planet moved through. Meaning that all the events that occurs on the planet as we move through space are imprinted or radiated into the vacuum in that very specific space-time coordinates. Why does that apply to psychology? Because when you understand that, you can actually get somebody to go back in time in their mind's eye, following the path, the true mechanical path of the planet through space. And go back to an event that was dramatic to them. And what you do is when they get to that point, and you know what? It makes a big difference. Because if you try to get people to do that with the wrong model, which is the planet coming back onto itself, after you've gone back 1 year, it's too confusing. You can't do it. You see why? Because all the space-time – overlap each other and it gets messy. But if you got the right mechanics, people can easily visualize that. They instinctively know how to go back. They back up the earth to the event that created problems in their life. And then what you do is you get them to visualize that event or to experience that event from the exact contrary point of observation, 180 degree from what they observed the event from. So if they had a traumatic accident or something, you get them to change. If they had like, sexual abuse or all sorts of abuse, you get them to observe the event, not from the place where they observed it then, but 180 degree reverse from where they observed it then. And, if they were the abused, then they become the abuser. If they were the abuser, they become the abused. And when they do that, the first thing they experience, it's very powerful, it's very dramatic, first thing they experience is empathy. Because they feel right away the pain and the fear and all the problems that this person was experiencing that made them have these actions. It's very powerful. And as soon as they do this, the 180 degree phase of the two waveforms of observation cancel the event. And all of a sudden, you can see it in their face, and I've done this many times now. All of a sudden, because it cancels out all of the geometry following that event in the vortex change to the present moment. And they change right in front of your eyes. Some people that had major physical problems just got rid of them right there. And then all of the future possibilities change as well, because that event is no longer present in their spiral lifetime. So that's one thing that's really interesting about that. And it's been very effective with Susie. Susie is still here? No, she's left. I'm collaborating, hoping to finish a book on the psychology of the application of this theory. See, it touches all levels because it is a truly unified view. So I was pretty excited about that. I realized what the wave was. It's a vortex. And I realized that the mechanics of orbital bodies in the universe are all vortices, spirals. But I was like, how do I make that, visually appropriate for people to understand? I was thinking, I went back to my van, and I thought, I gotta use something like a rotating motor or something, and a string. And so what I did is I thought, to show this to people, I thought, I'll take a rotating electrical motor, and I couldn't find one. I mean, I had the V8 motor in my van, but that was a little too big. So I looked around, and I finally found an electrical motor, but it was inside my razor. So I took my razor apart, and I have pictures of me now. Then I had to grow a beard because my razor was stuck in my experiment. But I took my razor apart, and I took the little electrical motor out, and I attached a string to it, a fishing line to it, and then on the other side I attached a little fishing weight that allowed me to hold on to the string and allowed the string to spin at the same time. So then I turned my razor on. Is there somebody, Andy, that can turn the lights off here? And I don't have my razor anymore because, well, you can see I started shaving again. But I was in a physics conference, and it was hilarious. I was going around all these physicists in this physics conference with my little laser and my little string, trying to explain to them that a wave is a 3D vortex. And some physicist that come from Canada saw me doing that, and he had brought this device that he thought was a cool toy. And when he saw me do that, he said, "You need this device," and he gave it to me. So since then I present with this, which is much better than my little razor string. Okay, so I'm going to try to do this in a way so I can build. Can you pull on that string above your head? There you go. Appreciate. So here, I orbited the string. And as soon as I put it together, this is what happened. The string self-organized into a vortex. But the vortex was quantized. Can everybody see the two-dimensional waveform here? The 2D sine wave? Okay, well, the 2D sine wave is a 3D vortex, right? We all agree, right? And when it does go into self-organization, it generates very specific quantas. Can everybody see this? These quantas are the particle, and this is the wave. You see? The wave and the particle come together naturally when you have a 3D vortex. You all see what I mean? All of a sudden, it's not either a wave or a particle, it's both in the same dynamics. The particle and the wave.
Now, when you disrupt that, it'll balance itself back out, right?
Pardon me?
When you disrupt it, it'll balance itself right back out, just like this.
Yeah, you can disrupt it, and you see, you can change the amplitude, but you can get like stable,
Chaotic contractor.
yeah, stable standing waves, like this one. And they're very beautiful as well. They generate really interesting fractal structures in between them, if you can see in the middle there.
Are those available to purchase?
I wish. I've never been able to find another one of these. And I looked hard and long. And you can continue to create. See, this is, let me see. This is a 2 frequency, right? So again, self-organized. Does that look like anything? Right. Now I had a contact for the petals, or for the lobes in between the intersecting spheres. The spheres are the radiating side of the event horizon. Those radiating spheres intersect, creating standing waves, that is the electromagnetic field. You see that? And so that you can actually make this the one frequency. Let me see if I can get. Let me spin it up. This is one of the interference patterns.
Now, a wave of water in the ocean coming onto a beach, is the water molecules coming in a spiral?
That's right. The water molecules are moving through the wave. You know, like surfers going through the tunnel? The water molecules are going through the wave like this along the shore. And the wave appears to be moving this way towards the shore. But it's actually a vortex. So, let me see. You can get, let me see if I can get it. Oh, way up. There we go. Here you get a tetrahedral array of waveforms in the middle. Oh, I lost it. Oh, sorry. It's kind of hard to show to a large audience. Need a camera on it. In any case, you can get all the interference pattern you need, including the wave and the particles together, all in one. You don't have to have some weird dichotomy between the two. And if you actually can get some really cool stuff. At slow speed. Here's the interference patterns at slow speed. Isn't this neat?
If you leave it long enough, does it always naturally organize itself, or is it organizing because you're moving it?
It's organizing because I'm moving it. If I change the wave frequency, right, there's places where the distance, due to the length of the string, will create interference, like here. But then if I change that length, when it's at the right length, then it will self-organize. And when it does, the rate of rotations of the motor changes. You see? And so it has to do with the wavelength and the speed of rotation. So here is my string theory. And so it became obvious that the wave and the particle are unified when you allow the spherical coordinates of the 3D vortex dynamic to be involved. Go ahead.
That relationship between the frequency and
The amplitude?
perhaps it's escaping me a bit, but is that the same dynamic as on the graph before between the frequency and the radius? I mean, is there
Yes.
is there a correlation there?
There's a correlation, absolutely, because it's the radius and the frequency will dictate the resonance of the system, will dictate the fundamental resonance of a system. So it's either in constructive or destructive resonance, and if you change the length of the string, you either get constructive waveform or destructive waveform, and the two generate, you know, the dynamics of the expansion and the contraction and so on. So yeah, it is definitely related. The radius of a system and its angular momentum are directly related, and its energy output, the surface of the system and the amount of information moving through it is directly related. So it all works together, you're right. So I guess I was really, I was amazed about that, because but then I was thinking, okay, you guys, this is where you guys are going to have to do some nonlinear thinking. Because I was thinking, all right, now, if you have a sun, a planet moving around the sun, right? But then the sun is moving around the galaxy. That's a larger spiral, because the galaxy is moving through space. And then the galaxy is orbiting a cluster of galaxies. That's moving through space. And then that cluster is orbiting a larger cluster, which is orbiting the universe, which is a larger spiral, and that universe is orbiting a multiverse, a larger universe, and a larger universe, and a larger universe to infinity. Then, is anything moving? That was a good question. That's where the fractals become a really good thing to have. Because in an infinite fractal of rotation, in an infinite fractal, how do you define the center? Every point is the center. You are the center of the universe, or observing the universe from your very own center. Wherever you pick a point of observation in the fractal, that point becomes the center from which you're observing the universe. That point becomes stillness. Why stillness? Because in that point now, all of the spins of the universe cancel out. For each spin you find, you'll find in the universe an exact and opposite counterspin. So all of the spin canceling out in each point creates stillness. I'll give you an example. How does here's a hurricane off the coast of Florida. How many, 100 miles an hour wind, 100 plus an hour wind, right? What's in the middle? Stillness, the eye of the hurricane. You need stillness to be able to have a frame of reference for rotation. You see? And that is how singularity occurs. Singularity is the point at the center of your experience of the universe, that's the point of stillness from which you're observing the universe. This is why, I say the universe is a fractal structure, and then people say, well, if that was true, we would all look the same. Well, we don't all look the same. Why? Because we're observing the universe from our particular point of stillness, our particular point of center. If we all observe this pan from our particular point of center, that means we're all going to get a whole different set of information about this pan. And because we all get a different set of information, we all look different. Can we have the lights come back on? That'd be great, because otherwise I get blinded by this one. Thank you. So, can you guys understand? Do you guys understand this? Right. So it's all spin canceling in the middle of all things, creating stillness. From that point of stillness, everything orbits around it. When you know that, then when you look at the galaxy, you find the same dynamics. Right? This is a galaxy. This is a huge fractal level larger than a hurricane. A hurricane is a few hundred miles across. A galaxy is a few thousand light years across. Okay? And it has billions of stars in it. What's at the center of a galaxy? An immense black hole. The point of stillness, singularity. The point where all spin cancels, creating non-movement, singularity. Yes, the black hole is orbiting, but that's the outside. If you go in towards singularity, further you go, stiller it's going to get, colder it's going to get. Now when I show this to people, when I showed this to physicists almost 12 years ago, I predicted from this theory that the center of all galaxies were going to generate black holes. That all galactic center had a black hole at the center. I got kicked out of physics conference for saying things like that. Well, recently, this data appeared. The largest Hubble the latest Hubble observations are presenting a cosmological challenge as astronomers uncover supermassive black hole at the heart of every galaxy they examine. That is a large prediction, you know. That is not trivial. Go ahead.
If you look at these pictures of the galaxy, you see that washed out thing in the middle?
Yep.
Right? If you look through like a 10-inch telescope, you don't see that big washed out. That's the film getting overexposed so they can see the outer edges. If you look at it through a small telescope, you can see a dot at the center of every one of these galaxies.
Yes.
And 20 years ago, I thought to myself the same thing.
Really?
When I started seeing that.
Oh, good. That dot you see in the middle of the galaxy is actually some of the brightest objects we observe in the universe.
And you never see that in any photo, ever.
Mm-hmm.
You can only see it through telescope.
Oh, that's good to know. You know, and they call it a black hole. Yet it's the brightest object we observe. Why? Why? Because we're observing the external part of that black hole, not the internal part. Right? So, you know, that was interesting. Here, astronomers are left scratching their head, wondering how these objects, once seen as novelty items or the stuff of science fiction, may be commonplace, dominating the core of possibly every large galaxy in the universe. Well, they keep scratching their head. Previously, supermassive black holes looked like pieces of custom equipment added to a car, said University of Michigan, da, 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 da. Now these look like standard feature, and if black holes are an integral part of galactic formation, that could require a major revision of our theories. No kidding. Maybe you don't kick people out so easily anymore. So you guys see where I'm going? See, this is the concept that I'm bringing forward. Everything is centered by singularity. And everything that is outside that center is the radiative part that we observe as the universe, because it rotates. Because it has angular momentum, and that generates forces like electromagnetic radiation and so on. So when when I was looking at all this stuff, and I realized that these lobes had to be those vortices that are moving through space, then I quickly seen that these vortices actually match the dynamics we see for the tensor equations of the electron clouds. The same dynamics are found at the electron cloud. These are the probability equations for electrons. And then I found, subatomic particles follow these dynamics as well. Mesons are vector equilibriums. Baryons are isotropic vector matrices. And then I noticed that's extremely small, right? Then I noticed that in the extremely big, the same dynamics are found. These are supernova explosions here on the right, on your left. And this is a crop circle. Can everybody see this here? It's hard to see. Maybe we can shut up the light. There you go. Is that easier?
Yeah, better.
When this occurred, I got really excited. I'm like, oh my God, they took a picture of the geometry of space. So I'm like calling my local astronomers and stuff. And I'm like, you guys took a picture of the geometry of space according to my theory. Those big loops that you see that makes petals, that's because, like a supernova explosion is a star that explodes, right? So you don't expect that it's going to organize in a very specific pattern. It's supposed to just go into a chaotic mess, right? But it didn't. This is the first supernova we ever photographed, and it made huge circles intersecting, making a petal structure. So I got excited. Well, they all told me I was full of what, and that this was just a random event. Well, from one random event to the other, they took picture of a next supernova, that exploded and generated exactly the same thing. Intersecting ring, making petal-like structures, just like what I had predicted. And then this one was really sweet because when you look closer in the middle, there was an eye, like the eye of Horus, even with a twinkle in the eye. But what got me really excited about that one is that the two intersect